Hello, everyone. Sorry, I'm a little late. I had a Windows update suddenly pop up, and it messed up with my audio settings. So let's start with the concept of remainders. So what we're going to do today is we're going to do a deep dive into the concept of remainders. I'm going to teach you a lot of properties which will come in very handy towards working with remainders. We're going to exhaust all the concepts that are required in this topic. I may put in a couple of extra just to cover all bases. And also, we'll work with a good set of questions that I have on a PPT, and if time permits towards the end, we'll also delve into a bit of exponents and work. I think we should have some time for exponents as well. So it's going to be a good 3.5 hour session, guys. So it's you need to be in for a long haul here. If at any point it's a little taxing for you, or you have a work day tomorrow at office, you're free to log out, and the recording is always going to be uploaded on YouTube. You can have a look at the recording. All right. So let's start. And like I said, hold on to your doubts. I will more probably than not take care of all of them. Right. Now, what I'm going to deal with here is my perspective of this entire topic. When I was learning this topic, it's the research that I have done and the structures I have made. I will also touch upon certain algebraic ways of working as well for people who are, well versed with algebra with remainders. So at any point, guys, when we're working with questions, you want me to explore the algebra aspect, feel free to ask me. We'll do that. But I will also do it in some questions to show you algebra works, but I'll also show you why at some points the algebra doesn't work as well. Okay, so today it's going to be a lot of patterns involved, a lot of numbers involved, a lot of structures involved. So be patient and take a book and jot things down. All right, great. So let's start with how I perceive what a remainder is. Okay, if I look at a remainder from a mathematical point of view, let's take an example. If I divide 7 by 4, when we work with remainders, we use the long division process of working. We divide 7 by 4. 4 goes to 7 one time. 4 ones are 4. And then 7 minus 4 is 3. This is the long division process you normally would make use to convert these fractions to decimals. We don't put the decimals, we stop at the point where we convert things to decimals, right? So remainders are like a precursor to you changing numbers into a decimal format. And this one is what we call the quotient. I'll write it fully. And this 3 is what we call the remainder, right? And this 7 is what we call the dividend, also represented as capital D. And the 4 is what we call the divisor, represented by small d. So when I divide 7 by 4, I'm going to get a quotient, let's call it Q, of 1. And I'm going to get a remainder, let's call it R, of 3. Yes? So this is the fundamental process of how you would normally understand a remainder, question. How I look at remainders from a very logical standpoint, right, is the dividend for me is always the number of chocolates. Okay, I look at it from a very commonsensical, logical standpoint. I've been taught math this way. So the dividend for me is always the number of chocolates in my mind. And the divisor is always the number of people. And I've been given the task of distributing these 7 chocolates among the 4 people. So now if I look at it from a real life setup, I have 7 chocolates and I have 4 people in front of me. Let's call them A, B, C, D. I'm first going to give each of them one chocolate, but I'm going to be left out now with three chocolates. And those three chocolates, I cannot distribute equally among the four people without breaking the chocolate into smaller chunks. So the quantity that I'm left out with, that I cannot distribute equally among the people, is what we refer to as the remainder. And what each person gets, the equal quantity that every person gets, is what we refer to as the quotient. So, from a very realistic standpoint, the quotient is what every person gets. The remainder is what is left out that cannot be distributed among the people there. Got it? So you can look at it from a, you know, mathematical aspect this way. You can look at it from a logical aspect this way as well. Now, let's look at the mathematical aspect a little bit. And the first concept that all of you all will know is the remainder formula. I'm still going to put this down, right? Because, like I said, we're going to do a deep dive on remainders. We look at all remainder concepts. We may not choose to use the remainder formula going forward, but I'll still put it across, right? So, how does the remainder formula come about? I'm just going to play around with the numbers that I've put in. Let's take the divisor 4. Let's multiply it with the quotient 1. And let's add the remainder 3 to it. You see what I'm going to end up getting? 4 into 1 is 4. 4 plus 3 would give me 7. That would be the dividend. So the remainder formula is that the dividend, capital D, is equal to the divisor, small d, into the quotient plus the remainder. So D is equal to dq plus R is what you would always look at as the remainder formula. This is an algebraic form of representing a remainder concept, right? Remember, the thing you'll have to keep in mind when you work with topics like statistics and arithmetic is that you can always convert statistics and arithmetics to an algebraic setup, right? By representing quantities in their algebraic forms. You can also use numbers to your advantage on statistics and algebra, statistics and arithmetic, right? So D is equal to dq plus R is the remainder formula, the algebraic form of working with remainders. What you have to keep in mind though, that the dividend, the divisor, the quotient, and the remainder, they are all integers. When we work with the concept of remainders, we only pertain ourselves to integers. You cannot have dividends, divisors, quotients, and remainders to be fractions or decimals. All right. So the first concept, what exactly is a remainder? The algebraic setup, looking at a remainder from a common sense point of view in terms of chocolates and people, and the first remainder formula, D is equal to dq plus R, where D, small d, q, and R are all going to be integers. And remember, D is equal to dq plus R is the process that you would employ if you want to approach a remainder question in an algebraic format. All right. So that's the first. Like I said, I'm going to deal with a lot of properties. Hold on to it. You'll see as we go with the properties, I'll take examples and we'll bring in the other processes of working as well. All right. Now let's delve a lot more deeper beyond the formula, okay, into certain properties. You can jot them down as properties. You can jot them down as pointers. Second, when you divide a number 7 by 4, we got to a quotient of 1 and we got to a remainder of 3. That's what we proved in the last discussion. So this is my dividend, this is my divisor. So it's safe to say that if my dividend is greater than the divisor, if my dividend is greater than the divisor, then my remainder will always be the excess after division. So what am I doing? 4 goes to 7 one time. I'm giving each one of the 4 people one chocolate. And what is left out after division that I cannot distribute equally is the excess. That would be the remainder, right? So whenever the dividend is greater than the divisor, the remainder will always be the excess after division. But what if I reverse it around? What if I ask you, what is the remainder when 4 is divided by 7? You can quickly type it in the chat window. What do you think is the remainder when 4 is divided by 7? Yes? There's two ways to look at it. When you divide 4 by 7, 7 goes to 4 0 times. 4 minus 0 is 4. This is my quotient. This is my remainder. Or you can look at it visually like how I do. You have 4 chocolates and you have 7 people. You have to distribute the 4 chocolates among 7 people. So obviously you give each of them 0 chocolates and you'll have the 4 chocolates left out with you because you cannot distribute those 4 equally among 7. So the quotient is going to be 0 and the remainder is going to be 4. Remember guys, these properties are actually patterns that you have to keep in mind. I'm just, making it as properties so that you can remember things better. So what is the pattern that I'm looking at here? If my dividend is lesser than the divisor, if my dividend is lesser than the divisor, the remainder will be the dividend itself. Right? The remainder will be the dividend itself. Always. Okay? The remainder will always be the dividend. It's very important for you to dive a little deeper on this topic if you want to bypass the formula. And we'll see how properties are going to help you out as well. So this is your second property. If your dividend is greater than the divisor, the remainder is always the excess after division. But if your dividend is lesser than the divisor, the remainder will always be the dividend itself. So if I give you a question like this, what is the remainder when 1932 is divided by 1931? I see that my dividend is bigger than my divisor. 1931 goes one time to 1932. What I'm left out with the excess, what excess I'm left out with is 1. But if I ask you what is the remainder when 1931 is divided by 1932, then 1932 goes 0 times into 1931. So the remainder directly will be 1931. All right. Any doubts? Great. Also, I want to add at this point, if I ask you what is the remainder when 16 is divided by 12, your answer should be a remainder of 4. What I see some test takers doing when they work with remainders is they simplify, they look at it as fractions and they simplify the numerator and the denominator. They simplify the dividend and the divisor. Remember, the dividend and the divisor should never be simplified. You don't look at them as fractions. They are like chocolates and people. You can't change 16 chocolates to 4 chocolates and 3 people. Okay? You have to respect what the dividend is. You have to respect what the divisor is. Do not simplify it to the lowest forms like what you do in fractions. And if I ask you what is the remainder when 12 is divided by 16, the remainder has to be 12. So keep in mind, do not simplify. the dividend and divisor as you do fractions. You have to respect the dividend, you have to respect the divisor. That's your second property. Be a little patient with me. You'll understand where all of this is going. You'll understand why it's also important when we go into an alternate process of working with the remainder. But these are very important for you to understand. Any doubts in what we've done so far? Guys? Anyone with any doubt? No? All right. Third. Now, when I divide, let's say we have a positive integer x. Okay. Let's say we have a positive integer x. And I ask you to divide x by 5. I'm just randomly picking some number 5. If I ask you to divide a positive integer x by 5, or basically if I ask you to divide any positive integer by 5, how many possible remainders will I get if I divide any positive integer by 5? Think through, don't rush through the answer. I'll repeat the question. If I'm dividing a positive integer by 5, how many remainders will I get if I divide any positive integer by 5? What are all the possible remainders? Don't forget that 0 is also a possible remainder, right? Yes. So think about it. If you're not able to get it directly, guys, there's absolutely no harm in listing things out. Take an example. 1 divided by 5 gives me a remainder 1. 2 divided by 5 gives you a remainder 2. 3 divided by 5 gives you a remainder 3. 4 divided by 5 gives you a remainder 4. 5 divided by 5 gives you a remainder 0. And remainders are always cyclic in nature, right? 6 divided by 5 again gives you back the remainder of 1, right? So whenever you divide a number by 5, you're always going to get 1, 2, 3, 4, 5 remainders. And the largest remainder will always be 1 less than the divisor. Right? What I'm trying to put forward here is a process of how you can break down questions and understand things better. So if someone tells me in a question, when x is divided by 5, you get a remainder, I know directly just by looking at that statement that I can only have 5 possible remainders: 0, 1, 2, 3, and 4. So the number of remainders will always be, the number of remainders will always be equal to the divisor that you have. The number of remainders will always be equal to the divisor. And the largest remainder will always be 1 less than the divisor. Always, the largest remainder will be 1 less than the divisor. I want you to keep this in mind. So when you see a remainder statement, don't just dive right in and create an equation out of it. Understand it. Similarly, if I ask you now, quickly, you can type in the chat window. If I divide any positive integer by 9, how many remainders will I get? And what would the remainders be? Right? If I divide a positive integer by 9, I'm going to get 9 remainders. And the remainders would be from 0 to 8. 8 would be the largest possible remainder that I can get. Got it? Similarly, if I'm dividing a number by 15, then I'm going to get 15 possible remainders, 0 to 14. Understanding this is important because when we use an arithmetic process of using numbers to approach a remainder question, we try to reverse engineer the understanding of this property. Now, I'm sure you would have seen remainder statements like this, right? When x is divided by 5, the remainder is 3. Now, what would be the algebraic setup of working with such a question? When x is divided by 5, you get to a remainder of 3. So the algebraic form will be, right, the dividend x is equal to the divisor into the quotient. I don't know what the quotient is, so I'm going to take it as q1 plus the remainder, which is 3, right? Somebody says, what if you divide 1000 by 9? Then it's a bigger remainder. The traveler, I mean, how can 1000 by 9 give you a bigger remainder? I think your understanding of division is a little awry. So you'll have to test that. So I'm doing the division for you. 9 ones are 9, 9 ones are 9, 9 ones are 9. And what I'm left out it is 1, right? So my remainder is 1. I think you're looking at the quotient and you're saying that the quotient is the remainder, right? The remainder is what is left out after division. Now, the thing with the algebraic form is there are advantages, there are disadvantages to algebra. If you set up questions in an algebraic form, you have to set them up correctly using d is equal to dq plus r. And you will have to manipulate the algebra in such a way that you answer what the question is asking. And at some points, the algebra might fail you. You will not be able to look at the patterns that are required, or you will not be able to proceed further with the algebra. So at that point, what happens? Test takers would go into putting in values. Some people start putting in values here as well. What I do is instead of going and setting up an equation and looking at an arithmetic question more in an algebraic form, I look at an arithmetic question like it's supposed to be looked at. It's number properties, right? I look at it in terms of numbers itself. So the question I'm going to ask myself is, based on what we've learned before, I'm going to ask myself, what is that first positive integer that when I divide by 5 is going to give me a remainder 3? Now, obviously, the first positive integer is going to be 3 itself, right? Remember what we discussed? When the dividend is lesser than the divisor, the remainder will be the dividend itself. So the lowest possible value, positive integer value of x, that when divided by 5, that will give you a remainder 3, is 3 itself, the remainder itself. So what I'm in a sense doing is instead of going with the algebraic form, setting up the equation and then plugging in, I'm just thinking of my understanding of remainders and asking myself, what should be the minimum possible value of x that when I divide by 5 should give me a remainder 3? Some people will say 8 because in their mind, they will always think that quotients can be 1, right? But quotients can also be 0, right? So the minimum possible value of x would be 3. And now once I get to the minimum possible value of x, all the other possibilities for x will be 5 units apart. All you have to do is add the divisor to the first number to get to the second, the divisor to the second to get to the third. So I'm just adding 5 to every element. And here I can nicely make a list of around 8 to 10 values. And I can use this list to my advantage. So this is the alternate process of working with the algebraic setup, where you're using numbers and patterns of numbers to your advantage, staying within the properties of the remainders to break things down, right? Similarly, if the question gives me a further statement, and tells me when the same number x is divided by 7, the remainder is 5. So x by 7 gives me a remainder of 5. So again, instead of creating another equation, x is equal to 7q2 plus 5, I'm going to ask myself, what should be the minimum possible value of x? When divided by 7, that will give me a remainder 5, 5 itself. And what should be all the other values? I'm just going to add the divisor to the first. That's 12, 19, 12, sorry, this is 12, 19, that's 26, 33, 40, 47, 54, and so on. So you see what I'm doing? Any remainder statement that is given to me, instead of setting it up algebraically, I'm looking at it from a very numbers understanding standpoint. I'm writing the minimum and then I'm forming a very structured list of values. The key word here is the word structured. I'm forming a structured list of values to break down that equation into a set of numbers rather than going and creating an algebraic equation out of it. So any remainder statement, you can translate it into a set of values, structured list of values like this. And what if they tell me that both these conditions have to be satisfied simultaneously? Or if they give me something like this, when x is divided by 5, the remainder is 3. The same number x when divided by 7 gives you a remainder 5. And they ask you what should be the least possible value of the number. Basically, I want values that satisfies both those statements simultaneously. So what would I do at that point? I've already created a list of values for my first statement. I've already created a list of values for the second statement. I need values that satisfy both statements simultaneously. That basically means I need a value of x that is common between the two structured lists. And the lowest value that I can find here that is common is 33. So if I need both my statements to be satisfied simultaneously, then 33 would be the common value. See, I'm taking the common process, right? I'm the process of taking the common value. Now, obviously, your question will be, but Aditya, okay, I've got 33 as my first common value. I can't run my analysis only with one example, right? If I have to take numbers that satisfies both the statements simultaneously. If I want to get to more overlaps between the two lists, it would be very tedious for me to continue writing the list in the first, continue writing the list in the second, and then get to the second overlap and then the third overlap. Yes, of course, it would be very tedious, but you don't have to do it. The best part about using the structured list of values, when you have multiple remainder statements, you obviously will get multiple lists. Write down the lists, take the first overlap, right? To the first overlap, always add the LCM of the divisors. What are the divisors here of your statements? 5 and 7. Always to the overlap, add the LCM of the divisors. So 5 sevens are 35. Basically, your first number is 33. All the other numbers on the number line are going to be 35 units apart. So your next number would be 68. You want the next number after 68, add 35 to 68, 103. You want the next number after 103, so 103 plus 35 would give you 138. So you don't need to extend that list beyond the first overlap. The first overlap is absolutely fine. From the first overlap, I can get to all the other values that overlap. Correct? So you see what I'm doing? Instead of going with equations and setting up equations for both those statements and then solving and then plugging in values for that algebra, my question was, why did I need algebra in the first place to use values, right? Why should I make algebraic equations, not be able to solve them, and then put values in those algebraic equations and get to the value of x? And instead of doing that, all I'm doing is I'm going with a structured list of values in the beginning itself. If I have multiple remainder statements, I would take the overlap. The first overlap is more than enough for me to figure out the other overlaps. All I have to do when I have multiple lists, consider the first overlap, add the LCM of the divisors to the first to get to, or to the first to get to the next to the next, to get to the next, so you can get to all the other overlaps. So now you can use these overlaps to your advantage to reason certain things out. So you see, even when I give you a statement like this, x divided by 5 gives you a remainder of 3, I can use my concepts of remainders that we've learned so far to figure out what possible values I can have for x. Same thing we did here. And the best part is, even if we have something like this, even if we have a statement where there are two unknowns, right? When x is divided by y, let's say, just assume that everything is positive integers here. When positive integer x is divided by positive integer y, the remainder is 12. Now, what am I doing? In the previous case, I at least gave you the divisor. When x is divided by 5, the remainder is 3. We had only one unknown, the dividend. But now we have two unknowns. Both the dividend and the divisor are unknown. But I've given you information about the remainder. I can still reason certain things out from this equation that is given. And that's the beauty of remainders. You can always reverse engineer your understanding of the concept. So now let's think about this, right? We've already learned this concept. Let's use that and work with it. When x is divided by y, you get to a remainder of 12. So the first thing I'm going to ask myself is, if I have to get to a remainder of 12, what can I say will be the minimum possible value of my divisor? Think about it. When we divided x by 5, the remainders we got were from remainder 0 to the remainder 4. So if I needed to get a remainder of 4, I know the divisor had to be a 5 minimum. I can also have a 6. When x is divided by 6, I'll get to a remainder of 0, 1, 2, 3, 4, and 5. So if I'm going to divide x by y to get to a remainder of 12, immediately just by looking at that statement, I can say that y has to be greater than or equal to 13. So the minimum possible value for y would be 13. It can be 14 as well, 15 as well, 16. I know for a fact that y has to be greater than or equal to 13. But I can figure out what is the minimum possible value of x. So even if y was 13, x, what divided by 13 will give me a remainder 12? 12 itself. So I know that the minimum possible value of x will be 12, irrespective of what value y takes. Even if y was 14, the minimum possible value of x will be 12. Even if y was 20, no problem. I know the minimum possible value of x would be 12. So just by understanding what we've learned so far, I can draw a lot of inferences from a remainder statement given to me. Right? When I had only one unknown, I could figure out all the values, all the possible values of that unknown. Even when I have two unknowns, I can get to, at least some extra information that I can glean from that statement. Got it? Any doubts here? It's a slightly tricky concept, right? I'm using what we've learned so far. So when I need to get to a remainder of 12, I know that y has to be minimum 13, because I can't divide anything by 12 to get to a remainder 12, or 11 to get to a remainder 11, right? It's not possible. Make sense? Any doubts here, guys? Any doubts on what I wrote here and the inference that I gleaned from that equation? When x by y gives you a remainder 12, that the minimum possible value of y would be 13, and the minimum possible value of x would be 12. Any doubts here? Yes, no? Okay. So let's look at an example. When a is divided by b, when positive integer a is divided by positive integer b, the remainder is 17. And when positive integer c is divided by positive integer d, the remainder is 13. So my question to all of y'all, What would be the minimum possible value of a plus b plus c plus d? Starting off with a very simple one. You can give me the answer quickly, and then I'll just make it a tad bit more difficult. Right? So when a is divided by b, when positive integer a is divided by positive integer b, the remainder is 17. When positive integer c is divided by positive integer d, the remainder is 13. What is the minimum possible value of a plus b plus c plus d? Break it down from what you learned. Learn to reason certain pieces of information given, right? It's not 50, Samiran. Is it 50? Yes. Is it 61? Some people saying 50. Some people saying 61. Okay, let's see. So a divided by b gives me a remainder of 17. So c divided by d gives me a remainder 13. And they're asking me for the minimum possible values. They're asking me the minimum possible sum of a plus b plus c plus d. And logic says if I want the minimum possible sum, I need the minimum values of a, b, c, and d. So I'm going to look at the first statement. When a is divided by b, I get to a remainder of 17. So what should be the minimum possible value that b can take? For me to have a remainder of 17, b minimum has to be 18. And what divided by 18 will give me a remainder 17? 17 is the minimum possible value for a. Similarly, c by d gives me a remainder 13. The minimum possible value of d would be 14. And the minimum possible value of c would be 13. So 17 plus 18 plus 13 plus 14 would be my answer. So 18 plus 13 is 31. 17 plus 14 is also a 31. 31 plus 31 would give me a 62. I saw many people giving me a 50 as an answer. Did you understand where your mistake lay, guys? Go ahead and in every video of mine, in the description, there will be my LinkedIn profile as well as my email ID. You can reach out to me through that. Okay. Why can't it be 0 and 17 for A and B? What is 0 divided by 17 when I do the division? 0 divided by 17. 17 zeros are 0. 0 minus 0 is 0. The quotient is 0 and the remainder is 7. Remainder is also 0, right? So how can you tell me that 0 divided by 17 gives me a remainder of 17? Think about it, right? You have 0 chocolates and you're going to divide it among 17 people. So every person gets 0 and what you're remaining is also, what you left out in your hand is also 0, right? So this is not correct, no? Yes? It's a tricky concept, guys. You need to be very, very good with numbers. That's why I said either look at remainders. If you're more mathematically inclined, look at remainders in terms of long division to understand things better. If you're more logically inclined, then it's always best to look at it in terms of visual representation, chocolates and people. You'll understand the question a lot better. Doesn't matter whether you're algebraically inclined or mathematically inclined or logically inclined. Both ways you can solve these questions, but it's always best to attack questions logically, because in the higher levels you'll be tested on that. Got it? Okay, I'm going to make this a little more difficult now. I want you to think through, and you see, now if I imagine, I want you all to go back maybe, and when you're looking at the video again, making your notes, the question that I just gave you here, try to work with it using the formula d is equal to dq plus r, and then try to reason things out. You can do it if you're good with algebra and understand the concept of remainders, but you'll realize that it's going to be a very difficult proposition for you to do so. Okay, so the best way to look at remainders, I feel the best way to look at number properties, the entire topic of number properties, is in terms of numbers and patterns. You can definitely convert it to algebra as well and work. But if you're converting it to algebra, remember your analysis skills with algebraic equations has to be really good. And at some points, you need to be flexible enough to put in values and work. My advice: attack a question from a mathematical standpoint and a logical standpoint first. When I say mathematical, I mean with numbers. In number properties, using numbers and patterns is much better than going and getting stuck with the algebra. Okay, you can definitely make use of algebra if you're good with algebra. If you ask me, I'm good with both. I still prefer to use numbers because I'm strong with numbers. So figure out which one you're more comfortable with, go with it. Number sense skills is something that will help you on number properties. Got it? So let's try one more. I'm going to make it slightly more difficult. When positive integer a is divided by positive integer b, the remainder is 13. And when positive integer b is divided by positive integer c, the remainder is 18. So my question: what should be the minimum possible value of a plus b plus c? Think through. I'll give you all a minute. Think through. Understand the difference between what I've given you here and what I gave you previously. I use A, B, C, D there, but here I've repeated B. So you can't have two different values for B at any given point of time. Okay, I see only two answers. Think through, think through. MXD, think through. Remember, I've used B twice, so you can't have different values for B at any given point, right? Okay, I'm getting different answers: 54, 59, 68, a bunch of 50s as well. Okay, let's work with it. When A is divided by B, you get to a remainder of 13. So the first thing I can do is I can say that I know the minimum possible value for B will be 14, and the minimum possible value for A will be 13. That's for sure. The minimum possible value of A is always going to be 13. But the problem is I have the same B here as well. So whatever value I take for B here, I have to take the same value here as well, right? I can't keep a different value for B here, a different value for B here. So if I take 14, 14 divided by C can't give me a remainder of 18. That's not possible. I can't have 14 divided by something to give me a remainder 18. Whatever value I take for C, if I take all values from 1 to 13, it's never going to give me a remainder 18. If I take a value of C beyond 14, the remainder is always going to be 14. So B is 14 is not possible. So I'll just analyze this as well. If B is divided by C to give me a remainder of 18, the minimum possible value of C, which has to be 19. And I know the minimum possible value of B has to be 18 here for this equation to be satisfied. So now I realize that, okay, since here the minimum possible value of B has to be 18, I cannot take the minimum possible value of B to be 14 here. I'll have to change it to 18 for it to satisfy both statements simultaneously. So the minimum possible value for B has to be 18. So 13 divided by 18 will give me a remainder 13. So the minimum possible value of A is 13. The minimum possible value of B is 18. The minimum possible value of B is 18 here. C is 19. So it's going to be 13 plus 18 plus 19. So 13 plus 18 is going to be a 31. 31 plus 19 would give me a 50. So those who got 50 were absolutely right. Got it? Any doubts here, guys? For those who gave me an answer other than 50, the catch was you had to figure out what B can take. In the first case, B could have taken 13 onwards, but in the second case, B could only take 18. So you had to respect the second and take the value of B as 18 in the first for me to figure things out, right? So you see, the point I'm trying to make here is even if I give you two unknowns, I can still use my information of the remainders to make certain inferences about the dividends and the divisors. Okay, and again, I would, you know, encourage you to put this in terms of equations and work. You'll realize it's going to be a very difficult proposition for you to figure this out. Got it? So let's consolidate this a bit, right? So the first process that you have available to you when you work with remainders is the algebra process, right? You can go with it. I have absolutely no qualms if you go with the algebra process, but understand the principles. When you're going with the algebra process, build the question build the question around d is equal to dq plus r, right? Set up the algebra efficiently. Algebra, simplify and break down wherever possible. Third, always manipulate the algebraic equations. Analyze or manipulate the algebra working towards the question. Fundamental rules of algebra apply here. If you've gone through my algebra session, you would see that some of the points that I've made are guidelines of how you break down algebra. And last, be flexible to putting in values if the algebra fails you, or if you're not able to look at the patterns, go with this. Got it? Tanish, I just proved the answer answer is 50, right? So 68, if you can type in how did you get that, I can touch upon that, right? The alternate process of working with, you can say for a remainder question, since we are pertaining to remainders, but this is an alternate process that will also work for other questions in number properties, even when you're working with concepts of factors, multiples, right? Structured list of values. The key word here is structured. I'm writing this in terms of remainders since we are pertaining the session to remainders, but you can use this process for other concepts as well, right? For example, if somebody tells me when positive integer k, when you add 5 to positive integer k, you get to a multiple of 4. Even if they give me a statement like this, instead of setting it up in terms of algebra, I would just say, okay, positive integer k, then added to 5 gives me a multiple of 4. So the minimum possible value of k will be 3, right? And then I can just go on adding 4 to it, 7, 11, and I can continue extending that list. So structured list of values need not only pertain to remainders. You can explore using values on other topics as well. Okay, number property is a very vast topic, so I'm pertaining to only certain important aspects of it. So what do you do in the structured list of values? Right, understand the statement that is given and always make a structured list of 6 to 8 values. See, one thing you have to understand, you also have to understand the downside and upside to using algebra, downside and upside to using numbers. The biggest upside of using algebra is very definitive in nature. Right? You can prove by getting the equation why something is definitely possible and why something is not. But if algebra fails, there will be points that algebra fails. You have to think of putting in values. That's the downside to it. The upsides and downsides for the structured list of values is the upside, I don't need to set things up with algebra. I don't need to worry about algebraical analysis. I don't need to worry about setting up equations and plugging in values. But the downside to using a structured list of values is it's not definitive in nature. So to make it more definitive in nature, it's always best for you to have a longer list of values. When you have a longer list of values, you'll be able to use that list to make an analysis much better. You'll be able to visualize and look at patterns between the list. Right? So make a structured list of values of 6 to 8, a structured list of 6 to 8 values, starting with the minimum possibility. Second, as you're making your list, look for any patterns between the numbers in the list. Sometimes you may have lists with patterns that you can identify. Sometimes there'll be a pattern between the units digit. Sometimes there'll be a patterns between, whether the numbers are evens and odds. All the numbers might be even, all the numbers might be odd. Look for any patterns between the numbers and use the patterns to your advantage. You'll understand it when you go into questions. Third, when you have multiple conditions, when you have multiple remainder statements, make multiple lists and consider the overlaps if you have to take the overlap. Remember, if you're forced to take the overlap, always learn to get to the first overlap. Get to the first overlap. And once you get to the first overlap, add the LCM of the divisors to get to all the other overlaps. Forgive my handwriting, it's too cursive. I hope you understand this. This is the two structures compared to each other. Okay. For people going with the algebra process and you're comfortable with it, please go ahead. Be flexible though to shift to the other process of working. For people more comfortable with numbers, don't want to go with algebra, stick to these guidelines of what I've put forward. Got it? All right. We'll look at some more properties, and then I'm going to, bring in a glut of questions, and we'll brainstorm on those questions. Okay. So we looked at 3 properties so far. I deviated a little, gave you a comparison between the two processes of working. Now let's look at other properties that will definitely help you out on questions. The 4th property. Okay. All right. Now, I want you to think about this, okay? What is the remainder when 16 is divided by 5? Sure, everybody quickly will give me the answer. The remainder has to be 1. Similarly, if I give you what is the remainder when 204 is divided by 5, you will tell me the remainder is 4. Similarly, if I divide 16 by 10, you will tell me the remainder is 6. And if I divide 204 by 10, you will tell me the remainder is 4. So, what do you notice? When you divide any number by 5 or by 10, the remainder will always depend upon the units digit of the dividend. So if I'm dividing 16 by 5, I get a remainder 1. That's the same as taking the units digit of the dividend, 6, and divide by 5. The remainder will always depend upon the units digit of the dividend. So the remainder will be the units digit divided by 5 or the units digit divided by 10. Look at this. 4 divided by 5 gives me a remainder 4. 6 divided by 10 gives me a remainder 6. 4 divided by 10 gives me a remainder 4. And this is a very nice pattern that you can make use that only holds good when you're dividing something by 5 and you're dividing something by 10. Okay? So remember, when you're finding the remainders, when the dividend is divided by 5 or by 10, then the remainder will always be the units digit of the dividend divided by 5 or the units digit divided by 10. Got it? Important pattern. This concept of remainders can also be clubbed with the units digit concept. Okay? And this will help you out, right? They can club the concept of a remainder with units digit. So whenever you see a question which tells you that something divided by 5 should give you a remainder, you know that your remainder will depend on the units digit of the numerator, of the dividend. Got it? That's your fourth property. Any doubts on this? Thank you for all the amazing, messages on the group, right? It's my pleasure to do these sessions, right? And I should really thank GMAT Club to give me the opportunity to do so, all right? Let's continue. Let's go into the fifth one. All right. Now here is where I'm going to speak about very important, something called the remainder rules. Okay. And I'm going to deal with this a little bit in depth so that once you understand it, you will know exactly how to work with it on questions. What are the remainder rules? Let's take an example, okay? Rather than just me giving you the rules, I'll take examples and prove it to you. So if someone asks me, what is the remainder when 15 times 15 is divided by 7? Basically, when I have the dividend as a product or an addition, and I have to divide it by something and find the remainder, I don't need to multiply the values and say 225 by 7 and then divide, saying 7 threes are 21, I'm left out with 1, 7 twos are 14, so that's my quotient, so my remainder has to be 1. I don't need to multiply my dividends to get to the remainders. So what does the remainder rule state? The remainder rule states that whenever you have a product or an addition or a subtraction of quantities as your dividend, and you need to find the remainder when divided by something, you can work for the remainders separately. So what is the remainder when 15 is divided by 7? 1. What is the remainder when this 15 is divided by 7? 1. So what will be my overall remainder? My overall remainder will be when 1 into 1 is divided by 7. 1 into 1 is 1. 1 by 7 gives me an overall remainder of 1. You see what I'm doing? I'm working with the remainders separately. 15 divided by 7 give me a remainder 1. 15 divided by 7 give me a remainder 1. So my overall remainder will be when 1 times 1 is divided by 7. 1 times 1 is 1. The remainder when 1 is divided by 7 is a remainder 1. And this will work across all kinds of values. If you have an addition, you have a multiplication or a subtraction on the numerator. We'll work with addition and subtraction as well. Let's take another example. Suppose someone asks me what is the remainder. Let's create some value. 79 into 67 into 49. And they ask you what is the remainder when this product is divided by 9. So I don't need to sit and multiply my numerator, right? I can work with the remainders separately. Should obviously be good with tables, right? At least tables up to 16. So 79 divided by 9. 9 eights are 72. So my remainder is 7. 67 divided by 9. 9 5s are 45. 6 are 54. 7s are 63. So I'm left with the remainder of 4. And then I have 49 divided by 9. That gives me a remainder of 4 as well, divided by 9. So some test takers will do 7 times 4 times 4. I won't do that. 7 times 4 is 28. I'll write this as 28 into 4 by 9. And now I can use the remainder rule again. 28 divided by 9 should give me a remainder 1. 4 divided by 9 should give me a remainder 4. So my overall remainder will be when 1 times 4 is divided by 9. That will be 4 by 9. That gives me a remainder 4. You see? I'm using the remainder rules. And it's a very, very important set of rules because it'll help you get to remainders quickly when you have in multiplication. Yes, we'll come to addition and subtraction as well. I'll show you how to work with it. Addition is pretty similar to multiplication. Subtraction, you'll need to know something extra. So it will work. When you work with a multiplication of values on your dividend and you're dividing something, you can work with the remainders separately. Whatever rules I'm giving you guys are rules that are set in stone. Okay, it's not like the rules will apply some cases but not apply some others. These are actual concepts of remainders. Okay. This will also work, like somebody mentioned, for addition as well, right? So if you have, let's say, what is the remainder when 15 plus 15 is divided by 7? You don't need to add it up and say 30 divided by 7 and then divide and say the remainder is 2. You can work with the remainder separately. When 15 is divided by 7, you get to a remainder 1. When this 15 is divided by 7, you get to a remainder 1. 1 plus 1 is 2. So 2 divided by 7 gives me a remainder 2. It will work for addition as well. So even if I have, and I want you all to do this, what is the remainder when 79 plus 67, I think, plus 49 is divided by 9? I'm just using whatever numbers I used before. I want you to give me what would be the remainder when this set of addition is divided by 9. Please do it and give me an answer. Type it in the chat window. Guys, be patient with me. Let's deal with the concepts, deal with the properties. When we go into questions, you'll understand how everything ties in together. Okay, I have a good set of questions. We will work a good number. I'm not going to rush through. Like I said, you're in for the long haul here, maybe till 1 a.m. So anybody feel free to log out if you're you're saturated beyond a certain point. I understand you have work tomorrow as well. You can always look at the recording. Okay, but before going, please don't forget to hit the like button and let the algorithm do its work. All right. So 79 divided by 9, I would get a remainder of 7. 67 divided by 9, I would get a remainder of 4. And 49 divided by 9, I would get 4 again. Yeah, you can add it or you can do 7 plus 4 and then do it separately. But I think the addition is pretty easy. 7 plus 4 is 11. 11 plus 4 is 15. 15 by 9, don't reduce it to the lowest form, guys. 15 by 9 gives me a remainder of 6. So the remainder rule also works for addition. The notes, I won't share the notes, Samiran, but I will definitely share the PPT where the questions are. I normally, at the end of the session, for the questions I may not be able to take during the session, I do write explanations for those and I send a PDF of the PPT. Okay. The notes, I think it's better for you to make once you look at the video again, right? Look at the video, make your notes on your own, and work. All right. You can take screenshots as well. No? So when you're looking at the video, you don't need to write it if you're tech savvy that way. Now, for somebody who asked me, does it work for addition as well? It does. It will work for subtraction as well. But with subtraction, there's one small thing you have to be careful of. It will work everywhere, but there's one small thing that I'm going to cater to. So let's take an example first. Let me create an example, a simple example, and let's see what problems sometimes you face with subtractions. Let's say, what is the remainder when 146 minus 29 is divided by 7? Okay, don't subtract the numerator and work. Try to use the remainder rule. I think you'll be able to get to an answer. So what do you get here? Let's work with it, right? So 146 divided by 7 should give me a remainder 6. 29 divided by 7 should give me a remainder 1. So 6 minus 1 is 5. 5 divided by 7 gives me a remainder 5. And if you subtract 146 minus 29 and divide by 7, you will see that you get to a remainder of 5 as well. But this is where subtractions become slightly tricky. You can still navigate through it if you understand the concept, but let's see what problems you face. And I want all of you all to give a shot at this, okay, using the remainder rule. What is the remainder when 143 minus 33 is divided by 7? Don't subtract, work with the remainder rule, and you tell me what is the problem that you're going to encounter. Guys, remember this is a deep dive, so I'm not going to directly give you the rules. I'm going to explain why and how the rules come about, okay? So basically, I'm giving you, I'm creating a remainder video here that should take care of remainders and more on what is tested on the GMAT. You get a negative, correct? And obviously, I can't have a remainder that is negative, isn't it? So you would get a remainder of 3 here. And when you do 33 by 7, you would get a remainder of 5 divided by 7, because 7 fours are 28. That will give me minus 2 by 7. So what would I write as the remainder here? And it's not 2. It just, you don't remove the negative. And obviously you can't have a negative remainder, right? Yes, somebody said minus 2, which is 5. So this is where I'm going to deviate a little into negative remainders. Ideally, remainders are not negative. When I say negative remainders, I don't mean that remainders are actually negative. It's how you look at the remainder concept. Okay, you look at the remainders from a very reverse perspective. So let's understand the concept of negative remainders first before we get to the answer to this. So when I divide a number 1 by 5, I'm always going to get to a remainder of 1. Similarly, 2 by 5 will get to a remainder of 2. 3 by 5, you'll get to a remainder of 3. 4 by 5, you'll get to a remainder of 4. Right? I've written these remainders. Now, when we look at negative remainders, we look at remainders from a reverse perspective. For example, when 4 is divided by 5, you get to a remainder of 4. Negative remainders is how much of a deficit is the remainder from the divisor. This 4 is 1 less than my divisor. So I can also say that the remainder is minus 1. And what does that minus 1 represent? The minus 1 represents that my remainder is 1 less than my divisor. It's how much of a deficit is the remainder from the divisor. So 3 by 5 gives me a remainder 3. This 3 is 2 less than my divisor. So I can say it has a remainder of minus 2. So negative remainders are basically how much, negative remainders are basically remainders which are that much lesser than my divisor. 2 gives me a remainder of minus 3, which is 3 less than my divisor. And 1 gives me a remainder of minus 4. This is what negative remainder concept is. Negative remainders are basically the actual remainder is that much times lesser than the divisor. So if I get a remainder of 4, that means it's 1 less than my divisor. My remainder is minus 1. Right? So if you get to a negative number here, you get minus 2, and you need to find out the remainder when minus 2 is divided by 7. Remember, when you have a negative remainder, it is always how much lesser is that number from the divisor. The divisor here is 7. Here you've got minus 2. So my actual remainder is 2 less than my divisor. And what is 2 less than 7? 5. That would be my answer. So with negatives, you have to be slightly careful because you may get a negative remainder, but you should know how to navigate negative remainders. Remember, when you have a negative remainder, it is that much lesser than your divisor. Got it? Any doubts on that? You can work with it and see. 143 minus 33 is, I think, is 110 divided by 7. 7 ones is 7. I'm left with a 4. 7 fives is 35. I'm left with a remainder of 5. See? So whenever you get a negative remainder, remember it's that much lesser than your divisor. All right? Any doubts? So it still works for subtraction as well, but you'll have to cater to the negative numbers when you get to negative numbers, when you subtract values. Remember, negative values, if you get negative values, it's just that much lesser than my divisor. Any doubts on this? Okay with this? Remainders is a very in-depth concept. I'm only going to deal with things that are pertaining to the GMAT, right? Negative remainders will help you in some way or the other on the GMAT. But there are other things as well that's called as Fermat's theorem and all of that I'm not going to touch upon that. Okay, so this is what you have. So what do the remainder rules say? So the remainder rules basically says that whenever you have an addition, a subtraction, or a multiplication of terms as the dividend, you don't need to do the addition, subtraction, and multiplication, right? You can always use the remainder rules, right? You can always use the remainder rules. You can work with the remainders separately. Got it? Work with the remainders separately. So if you have r into a into b into c and so on, you can write it as r of a into r of b into r of c. You can work with the remainders separately and then divide by that number to get to the overall remainder. And the same would work with addition as well, right? R of a plus r of b plus r of c. And subtraction also works. But when you're working with subtraction, sometimes when you get negative remainders, learn to approach the negative remainders like I showed you on the previous screen. Got it? Even when you're asked to find the remainder of exponents, you can still make use of this remainder rules. Think about it, right? What are exponents? What is 7 to the power of 15? 7 to the power of 15 is 7 into 7 into 7 into 7 into 7, 15 times, right? So it is a product of values on my numerator. It's a product of values as the dividend. So I can still make use of the remainder rules even when I need to find out the remainder of exponents. But if I'm working with exponents, I have to tweak my understanding of the remainder rules slightly, right? For example, the easiest example would be, what would be the remainder when 7 to the power of 45 is divided by 6? Right? If I give you a question like this, what is 7 to the power of 45? It is 7 multiplied to itself 45 times. So I can expand it in my mind like this: 45 times divided by 6. And we just learned the remainder concept, remainder rule. You can work with the remainders separately. So 7 divided by 6 is 1, 7 divided by 6 is 1, 7 divided by 6 is 1. So I'm going to get 1 into 1 into 1 into 1 into 1 45 times. So it will be 1 to the power of 45 divided by 6, and 1 to the power of 45 is 1. 1 divided by 6 gives me a remainder 1. So I can still make use of the remainder rules here. But the problem you're going to face, here this was an easy question. The problem you're going to face is when I ask you to find out the remainder when 7 to the power of 49 is divided by 9. Now here you're going to face an issue. So what do you do? What do you do when you see exponents, when you work with the remainder of exponents? First step, try to use the remainder rules directly. Okay, so let's see what happens if we try to use the remainder rules directly. 7 into 7 into 7 into 7, 45 times. If I divide by 9 and I use the remainder rules directly, it will give me back 7. 7 divided by 9 again give me 7. It's basically giving me back the same question, right? So I know I can't use the remainder rules directly. If you're not able to use the remainder rules directly, you can group quantities and try to get to a remainder of 1 or minus 1. Right? Try to get to a remainder of 1 or minus 1. Clubbing 7 square is not going to work, Abhay, because 7 square is a 49. 49 divided by 9 will give me 4, 4, 4, 4, 4, 4, right? So let's explore that. Somebody said you can club. Yes, you had the right idea, but the execution was not correct, because what I want to do is I want to club quantities, yes. But I want to club quantities such that I get to a remainder of 1 or minus 1. Why? Because if I get to a remainder of 1 or minus 1, the next remainders again will become cyclic in nature. Got it? It's like this. You can look at it as common sense, or you can look at it as cyclic patterns as well. So let's take 2. Okay, if I group 2 sevens, I'm going to get a 49. So 2 sevens multiplied will give me 49. 49 divided by 9. If I divide this by 9, if I take 2 sevens and divide by 9, it will give me a 4. Right? So what am I going to be left out with? 4 times 4 times 4 times 4 times 4, around 20, around 22 times, and then I'll have a 7 in the end, which is again very tedious for me to work with. It's going to be very, very problematic. So what should you do? Try to group terms such that you get to a remainder of 1 or minus 1. Normally on the GMAT, I think they will always give you an opportunity to work with 1. So look at this. Now, if I'm grouping 2 sevens is not helping. But if I group 3 sevens, what are 3 sevens? 7 sevens are 49 into 7. If I divide 3 sevens by 9, 49 into 7 by 9, this would give me a remainder of 4. This will give me a remainder of 7. 4 into 7 is 28. 28 by 9 will give me a remainder 1. And I want remainder ones, because if I get remainder ones, it's got to be easy for me in terms of calculation. And from that point, the values too are going to become cyclic. Yes? So I know 3. If I group 3 sevens, I'm going to get to a remainder 1. And I have a total of 45 sevens. Right? So how many groups of 3 sevens can I get if I have 45 sevens? I can just say it's 7 cubed to the power of 15. I'll have 15 groups of 3 sevens. And each group of those 3 7s, it'll be like this: 7 cube into 7 cube into 7 cube 15 times, and I'm not left with any value also. If I'm going to divide each of these groups of 7 cubes by 9, I know I'm always going to get to a remainder of 1. So I'll get a remainder 1 into 1 into 1 into 1 into 1 15 times. So 1 to the power of 15 will be 1. 1 by 9 will again give me a remainder of 1. You see? So you see what I'm doing? When I'm working with exponents, exponents are multiplications itself. But if I try to use the remainder rule directly with each individual number, if I'm not able to use it, then what am I doing smartly? I'm grouping the terms and I'm trying to get to a remainder of 1 or minus 1, because working with the 1 or minus 1 becomes easy. Okay, so I prefer doing it like this. Some test takers will also learn it as a cyclic process of working. So basically, it's the concept of cyclicity here. If I take 7 to the power of 1 and I divide by 9, so what they'll do is they'll try to make a cyclic process. 7 to the power of 1 divided by 9 will give me a remainder of 7. 7 square divided by 9, they group 2 7s. They'll say will give me a remainder of 4. 7 cube divided by 9 will be 49, will give me a remainder 1. Now see what happens after this, right? See what happens after this. When I take 7 to the power of 4 divided by 9, what is 7 to the power of 4? 7 to the power of 4 is 7 cube into 7 divided by 9. And I already know, using the remainder rule, that 7 cube divided by 9 should give me a remainder 1. And 7 divided by 9 should give me a remainder 7. So 1 into 7 is 7. 7 by 9 should again give me a remainder 7. So you see what happens? The remainders start becoming, after 1, they start becoming cyclic in nature. So basically what I'm doing is I'm using the cyclic pattern to my advantage. So every third power of 7, the remainders are becoming cyclic. I have 45 powers, so I have 15 such cycles, and I can work with that. Understood? Instead of doing all that cycles, what I do in my mind, I just group the terms and I see where I can get to a remainder of 1 or minus 1. So if you're given an exponent and you need to find out what is the remainder of that exponent by something, it's always best for you to use the remainder rule, but group the quantities together so that you can get, if you're not able to use it directly, group the quantities together so that you get to a remainder of 1 or minus 1. Use that to your advantage to figure things out. I'll do one more example. I know it's a tricky concept. I'll use one more example. Now, what if I change this to a 7 to the power of 47, right? Just for people who can visualize the cyclic pattern. So again, it's 7 into 7 into 7, 47 times this time, and I have to divide it by 9. Clearly, if I work with the numbers individually, it's not going to help me out. So I need to group terms, and I know if I group 3 7s, I'm going to get to a remainder of 1, right? So I'm going to now ask myself, how many groups of 3 7s can I form? No, it's not based on the units digit, Harsh, right? It's not based on the units digit of 7. I told you, if you're working with the units digit, see, some people will have this, confusion, right? When I'm dividing 16 by 7, if I divide 16 by 7, the remainder is not based on the units digit. That's only valid when you're working with 5 or with 10. You don't directly take the units digit and divide by 7, right? You're not going to get the answer as 6 here. If you do 16 by 7, you're going to get the answer as 2, right? So directly you don't take the units digit. Don't conflate this with the units digit concept, okay, in that way, where you have to find the unit digit of 7 to the power of 47 and divide by 9. That is not what I'm saying. I'm not saying find the unit digit of 7 to the power of 47 and then divide that unit digit by 9 to get the remainder. That is not correct. I'm proving it to you by taking a simple example. Remainder 16 by 7 is not 6 by 7. Remainder 6, it's 2. That unit digit will only work when you have the denominator as 5, the divisor as 5 or 10. Got it? So for those of you who had that doubt, don't conflate it by finding the unit digit of the numerator. What I'm doing is I'm grouping the terms and I'm getting to a remainder of 1. I'm not finding the unit digit of 7 to the power of 47. Got it? All right. Now, So again, I'm going to group the sevens. I have 47 sevens. So it will be 15 groups of 3 sevens. And I'm still left with 2 sevens, right? Since I have 47 sevens. And I have to divide that by 9. And I know every group of 3 sevens when divided by 9 is going to give me a remainder 1. So that's 1 to the power of 15, which is 1. And 7 square is a 49 by 7. So 1 to the power of 15 is 1. 49 divided by 7 will give me a 4. So 1 into 4 is 4. 4 divided by 7 gives me a remainder 4. That would be my answer. Got it? All of y'all, this is what I'm doing, right? So even if you have 7 to the power of 47, it's possible for you to work, right? You just have to visualize how many groups, how many, not pairs, how many groups that you can form, right? One group of 3 sevens form a remainder 1. So how many groups of 3 sevens can I form? What am I left out with? And then use the remainder rule for what is left out. All right. So I want all of you all to give a shot at this. Like I said, the GMAT will only test you on how you use numbers. They will not give you a question where you may have to use a formula. It'll be very difficult to do the multiplication, right? Oh, I'm so sorry. It's divided by 9. Sorry, it's divided by 9. My bad. Okay. 1 divided by 9 is 1. 49 by 9 is 4. So my remainder is 4 divided by 9, which gives me a remainder 4. Forgive me, I'm talking as well. I'm doing things here, so I may sometimes write something differently. Okay. All right, let's take another example. I want you all to solve this. I was crafting the next question in my head as well. So what is the remainder when 7 to the power of 47 is divided by, let's say, 16? Okay, give it a shot. All of y'all. Good. 4 of you all have given me the answer. I want all of you all to give it a shot, please. How many sevens will you group such that when you divide by 16, you'll get to a remainder 1? So look at it like that, right? Obviously, working with them individually is not going to help. So I'll have to group terms. So 1 7 is not going to help me. So 7 into 7, 49. 49 by 16. 16 threes are 48. Will always give me a remainder of 1. Correct? It'll always give me a remainder of 1. Guys, I cannot get a remainder of 23, right? That's not going to be possible when I'm dividing by 16. So you should think about your answer. Your answer has to be obviously from 0 to 15. So if you've got 23, you've done some error, right? So I know a group of 2 sevens when divided by 16 will give me a remainder 1. So the question I need to ask myself now, how many groups of 2 sevens can I form out of 47 sevens, right? So it'll be 7 square to 23, right? Because 2 times 23 would give me 46. I'm still left out with one more 7. So into 7 divided by 16. Yes? Now, 7 square. So 7 square to the power of 23 is basically 23 groups of 7 square, right? 23 groups of 7 square into 7 by 16, right? And every group of 7 square is going to give me a remainder of 1, 1, 1, 1, 1, 1, 1, 1, 1, right? So I know every group of 7 square is going to give me a remainder 1. I have 23 such groups. So I'm going to get 1 to the power of 23 into 7 divided by 16. 1 to the power of 23 is 1. So 1 into 7 divided by 16, right? And my remainder will be when 7 is divided by 16, which will give me a remainder of 7. That would be my answer. Make sense? So this is what you'll have to do, okay, when you're working with a question, right? Working with exponents, you can use the remainder rule, but when you're not able to use it directly, group the quantities and try to be smart, group the quantities and try to get to a remainder of 1 or minus 1. And the toughest questions on the GMAT, they will give you the opportunity to figure out the groups very quickly. Okay, they'll not give you numbers where grouping goes up to 5 or 6 terms. There is a way to solve that. That's using a formula. I don't think that is pertaining to the GMAT. It would be more for a CAT processor working. Okay. Any doubts on this? So the remainder rules, I'm expanding it into using to find the remainder of exponents as well. But the exponents, we have to try to group quantities and get to a remainder of 1 or minus 1. Make sense? Any doubts? You can, for example, okay, good question, Khadar. So why do I use minus 1? I don't think it'll be tested on the GMAT, to be very truthful, but I'm still covering my bases here. Suppose I ask you, what is the remainder when 30 to the power of 31 is divided by 31, right? If somebody gives me a question like that, then this is where the remainder of minus 1 is going to come into play. So 30 into 30 into 30 into 30, 31 times. If I divide by 31, I know I can't work with it individually. Remember, I don't have a calculator on my test as well, right? So 30 into 30 is 900. 900 divided by 31, I have to sit and do the long division to figure out what the remainder is. And if it doesn't work with 2, I'll have to group 3, 4, and so on, right? But if you look at it smartly, when you take 30 divided by 31, you get to a remainder of 30. I can write that as remainder of 30. My remainder is 1 less than the divisor. So I can write that as the remainder of minus 1. So 30 by 31, remember 30 when you divide by 31, you get to a remainder of 30. I told you I can represent it as negative remainders. So 30 by 31 can also be represented. My remainder is 1 less than my divisor, minus 1. So using negatives here would be more feasible for me, right? So I know this is going to give me 30 by 31 into minus 1 again into minus 1. And how many times am I going to get the minus 1? 31 times. So I can say it's minus 1 to the power of 31 divided by 31. Minus 1 to the power of 31 is minus 1. Minus 1 divided by 31 would be what I get. And remember, when we get a negative quantity, the remainder will always be 1 less than the divisor. So my overall remainder will be 30. I don't expect the GMAT to test you on this, but I'm just covering bases here. So you ask me where would a negative remainder make sense. So a negative remainder is basically, it's not a negative remainder as such, it's how much the actual remainder is lesser than the divisor. Got it? So this is where the negative minus 1 comes into play, because it'll be very difficult, no, for me to multiply 13 to 30, and if it doesn't work for 2, take 3, right? It's going to be ugly calculations, right? So sometimes when numbers are closer to each other, it's better to look at it from the negative perspective. All right. Good question, by the way, right? I can understand why. Like I said, there's a lot more, concepts on remainders that I should not be touching, because I told you the GMAT pertains to patterns and so on. It doesn't pertain to certain formulae. There are certain formulae, okay? There's a format theorem as well that I'm not going to touch upon at all, okay? Got it. All right. So that's your remainder rules, right? Now, armed with this set of concepts, armed with the processes of working, the algebra process as well as the process of the structured list of values, let's now dive into questions. Okay. I'm going to shift to a PPT that I have here. Let me know if you're able to see my PPT quickly, and then we'll go into the first question. Again, I've tried to put the questions in ascending order of difficulty level. So you'll find an easy one to get things started, and then slowly the difficulty levels increase. Okay, so be patient with me, guys. I told you I'm putting up a video there that will take care of everything that is related to remainders, a one-stop shop for everything. All right. Can you see my PPT? Not yet. Okay. All right. Let me share my screen again. Okay, should be up now. Let me know. Perfect. Okay, so I'm going to start with an easy one. To start off with, use the process that you're comfortable with. I would advise you to explore what we've learned so far, but let's work with this. This is, I think there's a error here. It's R square for people who cannot see that. Give it a shot. I'm going to give you only a minute for it. It's a very easy question. Your time starts now. Please don't type in the answers in the chat window. Okay, it's gone again. All right, just a minute. Share screen again. Screen share. Should be up. Okay, give it a shot, please. Sorry, guys. I think there's an update of Windows that happened, and I don't know what settings has changed. I need to figure that out, but I think it should be up now. Okay. A minute. Don't type in your answers in the chat window until I ask you to do so, please. You can start putting your answers in the chat window. Okay, starting with an easy one. Shouldn't take you too much of time. Okay, I see most of you have given me an answer. So I'm just going to use what we've learned so far, okay? But remember, guys, simple rules when you're working with questions on the GMAT, read and process the information step by step by step, okay? Don't rush through. If x is a positive integer and r is the remainder when x is divided by 4, so immediately when they're saying r is the remainder when x is divided by 4, I'll ask myself, okay, when I'm dividing a number x by 4, I should be getting 4 remainders. The 4 remainders being 0, 1, 2, and 3. Right? So I'll keep that in mind. My remainders can be 0, 1, 2, and 3. Right? You see, as I'm reading the question, I'm processing and I'm trying to use the concepts that I learned. And R is the remainder when X is divided by 9. So that's capital R. So immediately what will I say? My remainders have to be from 0 to 8. Right? This is capital R. This is small r. So the question now asks me, what is the greatest possible value of r square plus r? So obviously, if I want the greatest possible value of r square plus r, I'll need the greatest possible value of small r and the greatest possible value of capital R and add the two. So the greatest possible value of small r will be 3 square. That's 3 plus 8. That's 9 plus 8, which gives me 17. An easy one to start with. Anybody? I mean, it would be, you can explore this as well using equations. You can. Again, you'll still have to get to that point that when you divide a number by 4, you get a remainder of 0, 1, 2, 3. It boils down to that. Okay. Most of you all have got the answer here. So let's move to the next one. Let's give it a shot. I think we have to, yeah, that's it. Try it out, please. 2 minutes. Your time starts now. Please don't type in the answers in the chat window until I ask you to do so. Okay, you can start typing your answers in the chat window again. Think about what we learned, okay? Break down the question, make your inferences based on the remainder statements, and you should be able to get to your answer. There's around 30 and odd people in the logged in, so I would at least want around 16 to 17 answers. Only got around 5 or 6. For those not getting an answer, you can also type in what you're stuck with, okay, in your calculation. Any confusion, I'll try to cater to it. You can always type that in also in the chat window. Good. I think most of you all have given me the correct answer. Again, touching upon what we learned, I know A, B, C, and D are positive integers. I know the question says the remainder is 9 when A is divided by B. So immediately what I would do, I would try to reason things out. I would try to analyze this. When A is divided by B, I get to a remainder 9. So I know the minimum possible value for B would be 10. Basically, B is greater than or equal to 10. And the minimum possible value of A would be 9. And the second part says, and the remainder is 5 when C is divided by D. So C divided by D gives me a remainder 5. So I know that the minimum possible value for D would be 6, where D is greater than or equal to 6, and the minimum possible value of C would be 5. But what is my question asking? Which of the following is not a possible value of B plus D? So I'm just concerned with the values of B and D, right? So if the value of B has to be greater than or equal to 10 and the value of D has to be greater than or equal to 6, then the value of B plus D should be greater than or equal to 16, right? So I know the sum of B plus D will be greater than or equal to 16. So whatever sum I get, it has to be 16 or more. 20, 19, 18, and 16 all satisfy this condition except for E. That's my answer, right? A good question, very nice question, very nicely crafted question as well, that again makes use of the concepts of remainders that we've learned. Correct? Any doubts on this? I'm slowly making the questions more and more difficult as we move forward. Okay, so there will come a point where we hit the higher levels. Any doubts in this? We can move forward. Okay. Good question again. Let's try question 3. Again, 2 minutes. Think about what we've learned. Sometimes on questions, the GMAT will require you to figure out patterns using numbers directly, okay? And then use your patterns to figure things out. Got it? If you're smart with the numbers, you're smart with working with numbers, looking at patterns, and getting to an answer, you normally will be able to pick an answer very efficiently. If you try going into, working with it algebraically, you'll have to run through cases. So my advice, if you're working with remainder questions, use numbers and try to reason things out rather than going with algebra. Give it a shot again. 2 minutes. You can start putting your answers in the chat window. How I treat remainder questions and even sometimes statistics based questions is very similar to what you would do in critical reasoning, right? You would always try to eliminate and get to an answer, but you wouldn't go and you know justify the answer. You wouldn't go and try to justify the answer on test day, because that's going to make it more confusing. And remember, your job in a critical reasoning question is also to pick the best possible answer out of the answer choices, right? So look at questions of this also in that kind of way. Okay, if you're able to find a pattern and that pattern holds for a good set of numbers, doesn't hold for different other kinds of values, right? Trust in that intuition, trust in that pattern, and pick an answer. All right. It's a good question again. So positive integers a and b. The remainder when a is divided by b is equal to the remainder when b is divided by a. Now, when I see this, my first instinct is to try and figure out when is this possible? You remember when we learned the properties of a remainder, I said when the dividend is greater than the divisor, the remainder is always the excess after division. But when the dividend is lesser than the divisor, the remainder is the dividend itself. So I would try to figure out what possible values can I take for a and b such that the remainder when a is divided by b is equal to the remainder when b is divided by a. So how would I run it in my mind? They've not limited me to what kinds of values I'm going to use for a and b. So what would I do? In my mind, I would think of different cases. What if my dividend was greater than my divisor? Let me take an example there. What if I take 3 divided by 2? Right, so this is your a, this is your b. So here I would get to a remainder 1. But now they're asking me, is it equal to the remainder when b is divided by a? So if I take the reverse, 2 divided by 3, then my dividend would become lesser than my divisor, and there my remainder would be 2. So I know it's not going to help me out, right? Because the remainders are not going to be equal. And I'll take another example. 7 divided by 4. That's going to give me a remainder 3. But if I flip the dividend and the divisors around, 4 divided by 7 is going to give me a remainder 4. So what is the conclusion that I can reach? That if my dividend and divisors are different, I'm going to get different remainders always, even if I flip the dividend and the divisors around. What if I keep my dividend and divisor to be equal? When 4 is divided by 4, the remainder is going to be 0. If I flip it around, it's also going to be 0. So the only way I can have the remainder of a by b to be equal to the remainder of b by a is when both my dividend and divisors are equal to each other. Because if they are unequal, I will never have the remainders to be equal. You see, I'm using these patterns to reach that conclusion. So what does that mean? For this statement to hold good, I need a to be equal to b. That's the only possibility. And the questions ask me which of the following could be the value of the product AB. So if I need a product AB, I know A is equal to B. It is A square or B square. So basically it has to be a perfect square. Now when I look at my answer choices, 24 is not a perfect square. Neither is 30. The only possibility is 36. B. You see, again, I'm using numbers in a very structured manner, patterns, right, and the concepts that we've set up to reason things out. More tougher questions will require to reason things out from the concepts that you know. Got it? Remainder questions are not only d is equal to dq plus r and then set up and manipulate the equations. Okay, there's a lot more to it than the remainder formula itself. Very good question again here, right? Shows you how you need to work with patterns to your advantage, how you need to figure things out by taking examples and then run through your analysis. All right. Any doubts on this question? You see all those properties coming in now, right? How I'm using that fundamental knowledge of the properties rather than only going with d is equal to dq plus r and working. And you'll see that that's going to carry forward as well, going further. Any doubts, guys? Can we move on to the next question? I have a good set of questions today, right? May not be able to solve all, right? But I'll definitely give you the PDF of the PPT. Any doubts here? We can move on to the next line. Okay. So here's question 4. Again, read the question carefully, right? And work with it. Give it a shot. 2 minutes. Please do not type in the answers in the chat window until I ask you to do so. To be very truthful, this question can be solved in under a minute if you're able to process the question well. Okay? You can start putting your answers in the chat window. Good. I see a good many of you are giving me an answer. I'm glad that you're breaking down the question, trying to analyze rather than just dive into the formula. Like I said, if you have good knowledge of the concepts, this can be solved in under a minute. For those not getting it, please don't refrain yourself from typing what you're getting stuck at in the chat window. I will cater to it. Okay. Great. So good answers. The right answers as well. So let's break down the question. The key lies in the question itself, right? If you're able to break down the information in the question, pick some numbers as an example and work, you'll get the answer to this in under a minute. When each of the 5 positive integers, you see how I'm reading? I'm reading slowly. I'm making a note of the constraints. When each of the 5 positive integers in the list A1, A2, A3, A4, A5 is divided by 5, the remainders are all different. So if I have 5 numbers, 5 positive integers, and I'm going to divide each of them by 5, if the remainders all have to be different, I know if I divide any number by 5, I can only get 5 possible remainders. 0, 1, 2, 3, and 4. So if the remainders all are different, A1, A2, A3, A4, and A5 have to be numbers which when divided by 5 gives you a remainder of 0, 1, 2, 3, and 4. I'm constrained only to positive integers, so I can keep a1 as 1. 1 divided by 5 will give me a remainder 1. 2 divided by 5 will give me a remainder 2. 3 divided by 5 will give me a remainder 3. 4 divided by 5 will give me a remainder 4. And 5 divided by 5 will give me the last remainder, which is 0. For people who use 0, 1, 2, 3, 4, that would not be correct because the question constrains you to positive integers. Right? So I know a1 is 1, a2 is 2, a3 is 3, 4, 5. You can take any of 5 other consecutive numbers as well to satisfy the condition. I'm just going to run with this example. So the question further says, when the 5 integers in each of the following lists are divided by 5, and I look at the following list, everything deals with something added to a1, a2, multiplied, squares. For which of the lists are the remainders all different? So let's take the first, a1 plus 2. So a1 plus 2 means you're adding all of these, you're adding 2 to all of these values. So it would be 3, 4, 5, 6, 7. If I divide all of these numbers by 5, the remainders would be 3, 4, 0, 1, and 2. So the remainders are all different here when I divide those numbers by 5. 1 definitely holds. Let's take the second. 2a1, 2a2. So basically, I have 1, 2, 3, 4, 5, and they're asking me to double each one of the values. So 2, 4, 6, 8, and 10. Can use your remainder rules as well, but let's run with this. The remainders will be 2, 4, 1, 3, and 0. Again, giving me all different remainders. 2 holds. And the third, a1 square, a2 square. So I have 1, 2, 3, 4, 5. a1 square is 1, 4, 9, 16, 25. If I divide by 5, I'm going to get to a remainder of 1. I'm going to get to a remainder of 4, and 4 repeats, so they are not different. I stop there, eliminate 3. So I'm left with 1 and 2 only, delta. All right? So you see how breaking down the question using the understanding of remainders will help you use values to your advantage and break things down. Got it? Any doubts on this? We can move further as well. Any doubts? Okay, let's move to question 5. Again, give it a shot. No, the question is for which of the lists are the remainders all different, correct? So I need the remainders to always be different. Two minutes. Give it a shot, guys. Ankit, the safest thing to do, like I said, right, you have to have a critical reasoning mindset. Right? After eliminating 4 answer choices, I wouldn't go on test day and go and critically analyze the validity of the answer choice that I'm left out with. Right? So in numbers as well, they expect you to use patterns up to a certain point. Obviously, that's why I mentioned in the beginning, if you're using numbers, it's not foolproof. So to make it foolproof, if you're able to use 5 to 6 possibilities, then it holds for a good 5 to 6 possibilities. It's enough for you to reach that conclusion. I agree. It's never, 100%, definite. For that, you'll have to maybe set up things with algebra, but you can't set up all questions with algebra. Okay. So you'll have to have that critical reasoning mindset of picking, so make a longer list and test for at least 4 to 5 possibilities. Okay. So maybe in the previous question, if you want to test for another set, take another set of 5 numbers, right? So you could have taken, 5, 6, 7, 8, 9. That's also possible. And test for it. And you see it will hold good. That's enough for you to work and move on. Okay. Vishwanath, now I understood why you asked this is a could be question. It's not, right? But think about it, right? If I take any set of 5 consecutive numbers, if I add 2 to it, it's like pushing the same numbers. It's consecutive still, right? So the remainders would be the same. If I multiply, it would still be the same. If I square it, obviously the values would change. So if you're in doubt, you don't want to test for only one possibility, take another example. If it still holds, that's enough for you to reach a conclusion. You have to understand this when you're working with values in any question on the GMAT, whether it's data sufficiency, whether it's number properties or stats. You'll have to run through your analysis by a couple of examples. Guys, remember, most of the questions that I pick in my sessions are official retired GMAT questions. Not all, most of them would be. So you understand that, how the GMAT crafts a question would be for you to work with those patterns. It doesn't expect test takers to only go with a algebraic way of working. That's why I said have a critical reasoning kind of mentality. You're able to see the patterns with two possibilities. Take a leap of faith, stop, pick, move on. Okay, last call for answers on this question again. Everything lies in the question stem. If you're able to break down the question stem well, you're able to use the concepts that we've learned, you should be good to go. What I would definitely encourage you to do, I can't do it in the session here. This is how I learned when I was preparing for the GMAT, especially on this topic of remainders. What you see me teaching, now as I've grown older, is what I did, what I learned when I was preparing for the test. Okay, so when I was learning concept of remainders, I took up every question. I obviously had a structure in my mind how to work. I did get to the answers, but I always reviewed the question and I also used the algebra process and I tried to make sense of it. So, what happens when you do it in the alternate process as well? Your decision making becomes sound, right? You understand where you can use the process of algebra and where you can't. What would be a better choice on certain questions? So at the end of the session, once you go and make your notes and you work with the questions, I definitely encourage you to approach these questions from an algebraic standpoint as well and see how it works. All right. All right. Let's work with this question. For a non-negative integer k, immediately when I see this, right, it should ring a bell in your head. Non-negative means what? It's not positive, it's 0 or positive, right? So k should be 0 or positive. I put a box over it. Anytime you see the word non-negative, 0 becomes a very crucial aspect that you'll have to consider. If the remainder is 1, when 2 to the power of k is divided by 3, so 2 to the power of k when divided by 3 gives me a remainder 1. Then which of the following must be true? So let me try to break this statement down. Either you can go with the algebra process, create equations and reason, or you can think of numbers. I know k has to be any non-negative integer, so 0 or anything positive. So I'll ask myself, if I put k is equal to 0, I'll just create the list of values. If I put k is equal to 0, 2 to the power of 0 is 1. 1 divided by 3 will give me a remainder 1. So I know I can put k as 0. But if I put k as 1, 2 to the power of 1 is 2. 2 divided by 3 is not going to give me a remainder 1. But if I put k as 2, 2 square is 4. 4 divided by 3 is going to give me a remainder 1. So I can put k as 2. Immediately I look at a pattern, okay, that's evens. Let me go further. Let me test for at least 4 to 5 values. If I take k as 3, 2 cubed by 3 is going to give me a remainder 2. If I put k as 4, 2 to the power of 4 is 16. 16 by 3 gives me a remainder 1. So k as 4 is possible. I'll go for one more. 2 to the power of 5 is 32. I see that's going to give me a remainder 2, but 2 to the power of 6 is 64. 64 by 3 will give me a remainder 1. So k is 6. And now I know that pattern is going to hold. And what is the pattern that I get here? That k has to be even, 0, 2, 4, 6. Because only even values for k would give me 2 to the power of k divided by 3 to give me a remainder of 1. Right? Odd values are always giving me a remainder of 2. So the analysis that I can, or the inference that I can draw is that k has to be an even number. Right? So I'm going to look for 4 to 5 possibilities, reach that conclusion, then I'm going to go into my statements. K is greater than 0. No, need not be true always. K can also be equal to 0 because it told me k is a non-negative integer. So 1 is not true always because k can be 0 as well. 3 to the power of k is equal to minus 3 to the power of k. So I know k is going to be an even value. So 3 to the power of 0 is 1, minus 3 to the power of 0 is also 1. Anything to the power of 0, any integer to the power of 0 is always, any positive or negative integer to the power of 0 is always 1. And even if I have an even exponent, right? So the even exponent will negate the negative value. So 3 square and minus 3 whole square would give me the same values, right? Since k is even, these two will definitely be equal to each other, two wholes. And the third, root of 2 to the power of k is an integer. And I know k is even, right? So root of 2 to the power of k, 2 to the power of 0 is 1. Basically, when I take the root of 2 to the power of k, and since I'm dealing with k as being a non-negative integer, I know k is always going to be an even value. And if I take the root of an even power, it will always divide by 2, and I will always get an integer output. You can put it and check if you want. 2 square would give me 4. Root of 4 is an integer. 2 to the power of 4 is 16. Root of 16 is an integer. 2 to the power of 6 will be 2 cube, which is also an integer. So whatever values I put for k, because k is even, root of 2 to the power of any even will always give me an integer output. 3 wholes. So the question is, which of the following must be true? 2 and 3, echo. Again, a beautifully crafted question. Right? And you see how patterns are going to help you out. You can always explore the algebra process as well. Make an equation saying 2 to the power of k is equal to 3q plus 1, and then run your analysis based on that. Okay, you can definitely explore that once you go back, you make your notes, and you take the questions again and work with it. Got it? Any doubts on this, guys? All of you are okay with this? Can we move on to the next question? Any doubts? No? Okay. All right. Let's try question 6 as well. And then we'll take a break, maybe for 5 minutes, and then continue from that point. 2 minutes, give it a shot. You can start putting your answers in the chat window, please. It's a question you can also work nicely with algebra. Numbers also works really well. Great. So I see most of y'all have given me the right answer. So let's discuss. When positive integer x is divided by 5, the remainder is 3. So either you can put it in terms of an equation. Like I said, I'm avoiding trying to use the formula. So immediately I would say, okay, this is 3. I'm going to say the first number for x when divided by 5, that gives me a remainder 3 is 3 itself. The next is going to be 8, 13, 18, 23, 28, 33, and so on. And the same number x when divided by 7 gives you a remainder 4. So remember, I have two remainder statements. So basically, I need to pick values of x that satisfy both statements simultaneously. So the first number when divided by 7 that gives me a remainder 4 is 4 itself. 4 divided by 7 gives me 4. The next number, I'm just going to add 7 to it. That's 11. I add 7 again, that's 18. Immediately, I know I'm dealing with two remainder statements. I'm making two lists. What I require is an overlap. As soon as I get my first overlap, I would stop. Because I know from my first overlap, I can get to all the other numbers that will overlap by just adding the LCM of the divisors. So 5 and 7 gives me 35. So 18 plus 35 would give me 35 plus 15 is 50, would give me 53. So that's my second number. 53 plus 35 would give me an 88, and so on. So x would be 18, 53, 88, and so on. And the best part, if I read the next part of the question, they're giving me the same two statements for y. So y also has to be 18, 53, 88. I'm not going to waste my time and solve for each of the values of y when exactly the statements are the same as what they've given me for x. So immediately I've got what possibilities x can be, what possibilities y can be. And the question is asking me if x is greater than y, which of the following must be a factor of x minus y? So I need to pick two values where x is greater than y and see what happens when I have x minus y. So if I take 53 and 18, if I take x as 53, y as 18, x minus y would give me 35. That's the lowest values I can take, remember, where x is greater than y. If I take x is equal to 88 and y is equal to 18, I'll get x minus y as 70. And if you want, you can do 88 plus 35, check for one more. That's 13. That's 1 plus 8, 9, 123. So 123 minus 18 will give me x minus y is 123 minus 18 will give me a 104, right? That will give me 105. That is 35 times 3, right? So I know the values of x minus y is going to be 35, 70, 105, and so on. And what do I know here? All of them, the lowest value would be 35. All of them are multiples of 35a, right? So you see what I'm doing? I'm using, again, what we've learned in terms of creating the structured list to work. You can also use the equations as well. I think it should work out in this question as well. Explore that option. when you go forward. You'll realize, right, and on questions, when you explore the options on certain questions, it'll be very difficult for you to work with the algebra. In some, it'll work, and that's why I'm always, um, say, telling you to work with the values of. I mean, working with values on a question, because it'll always work out, irrespective. The only downside is you may not it'll not give you definitiveness, but if you take around 4 to 5 values and then look for patterns, that patterns holds, and those patterns hold, pick the answer and move forward. All right, any doubt again on this? Okay, can't we deduce that the LCM of the divisor is going to be a factor? Yes, of course, of course. Yeah, I don't want to get into, you know um, technicalities there. I know it's a property. Yes, if I take the LCM, then they have to be 35 units apart. So they have to be, the difference has to be 35. You're absolutely right. Right? You're absolutely right. Yes, if you understand that, that's very good. Okay, because every number is 35 units apart, right? So if every number is 35 units apart, whatever two numbers you take, the difference will always be a multiple of 35. Absolutely right, Vishwanath, right? But think about it, no? The reason I work with it is I don't expect all test takers to be able to identify that directly, right? So even if you're not able to identify that they're 35 units apart, so any difference is a multiple of 35, listing around 4 to 5 values, taking a couple of examples will absolutely give you the answer. Okay, if you understood that, you're on the right track, Vishwanath. Okay, fantastic. Okay, I think the times is 11:30. We've sat for around 2.5 hours. Um, I'll give you like a 5-minute break. You can grab a bite to eat, drink some water, use the washroom, and we'll start exactly in 5 minutes. Okay, we'll work with some more questions and make it more harder as we progress further. We'll look at one aspect of remainders as well, where I compare remainders to decimals, and then we'll go into working with exponents. 5 minutes, I'm still here. So anybody would want to revisit something or ask me any question, you're free to do so. Guys, I'm going to maybe take the session till around 1 or 1:15. So if it's too late for you, you can always look at the recording, once it's uploaded on YouTube. All right, 5 minutes. We'll be starting in exactly 5. Yes, Kadar, I do one lecture in around 3 weeks, 3 to 4 weeks of time. Okay, so I think I have another 2 lectures that I'm going to do for GMAT Club. Right, so time and work, I think, will be one. The last one I'm undecided yet, so you're free to put in what topics you want. Let me consider. I'll be doing time and work. I don't think I'll be able to cover speed, distance, and time along with that. Okay, be too much of a overkill. So I would work with time and work, independent work, group work, concept of proportions, how to set up rate work time. Yes, so I think my next session would be time and work related. My last session is open to discussion. I was planning to do absolute values, but I think, many said there's already an absolute value session I'd taken some years back. So that should be enough. So they wanted something new. So my last discussion is still open. Okay. So next would be time and work. Ratios and percents. Okay. I don't know if everyone um, would put ratios and percents as a tough topic for themselves, right? Normally, if you struggle with ratios and percents, it's normally the breaking down the verbose information into algebra that's the one that you'll have to work on, right? So working on how to break down word problems is the key. Otherwise, you know, how to look at a percentage, everybody would already know what a percentage is, right? It's about breaking down the question step by step by step. Word problems. Okay. So when you say word problems, what do you do? Basic word problems, because word problems will include rates, ratios, percents, mixtures, interests. That's not a good topic, no, for me to discuss in a 4-hour discussion or 3-hour discussion. Got 81 in quant. I want to try and get the maximum possible score in it. Balance out any loss in DI. See, MXD, I wouldn't suggest that's a nice strategy to work with. Okay. Yes, you can think of pushing your quant to the maximum possible, but think about it like this. Worst case scenario, even if you make one or two mistakes, the quant scale is so sensitive that you may drop to a 84 or 85, right? So if you want to guarantee something like an 87, you can only afford a mistake, or you get everything correct, right? And that would depend on how you perform on test day. So taking into consideration that you make two mistakes, and it drops, I think targeting an 84 and 86 would be ideal. But then that means you still have to work on the DI section. Okay, I see many test takers having that strategy. Try to maximize quanto a 90, right? And they say I can lose out a little bit on verbal. If I My advice to them, do quant. Obviously quant is a strong point. Do it as best as possible. Even if you get a mistake, it's okay. Your score might drop to an 87, 86. But I would look at improvements on the verbal front. Okay, so if you're looking at, normally target scores around a 675 or a 695 and so on. So if you're looking at a 675 and 84 across the board is ideally the magic figure, right? 84 on quant, 84 on verbal, 84 on DI. The more you get on quant, obviously you can afford to lose a bit on DI, but you know I still cannot afford to allow DI to go less than an 82 if you're looking at a high score. Okay, so I would say work on the DI front. DI requires a lot of practice, and it requires you to get better at decision making as well. So it's better for you to improve those skill sets rather than push and try to get to all questions right. If you get all questions right, there's nothing better than that, but expect you to make one or two errors, okay, on test day. You can't predict that, right? So smarter thing to do, maximize quant, but also work on DI and ensure that you have at least a minimum of 82 on DI. Okay. What problems are the problem with that, right? Is I'll have to build from basics on how to break down verbose information. Okay, and only once I work with that and break it down and see how to translate, how to set things up, then only I can bring in complex questions. Understood? So it wouldn't it would be a rush job if I do it in around 3 hours. Normally when I take personal tutoring, word problems, basic word problems itself takes me 2 sessions, and rates, ratios, percents, and all of that, and again takes me around four, right? So it's a very huge concept. So that's why I'm touching upon specific things like time and work, which will touch upon how to break down word problems as well. What is the best way to revise quant topics? Once you've gone through all the quant topics, why must you go through the quant topics to revise then later? You should always dedicate one day in a week for revision. Okay, that's something that I always tell my test takers. A Sunday should always be dedicated towards revision. Okay. All right, let's start. Let's continue with the next question. I'm going to skip the next. Yes. And I'm going to give you an application based question on remainders. We'll work with a couple of application based, and then we'll go into a couple of data sufficiency ones as well. Okay, give it a shot. Question 8. Understand the question, guys. Okay, link it to the concept that we've learned, and then set it up carefully. Okay, you can start putting your answers in the chat window. Ara, the time and work session will be 3 weeks from now. Okay. Okay, last call for answers. Then we'll discuss. Tougher questions are never going to directly tell you it's a remainder concept. Okay, you'll have to visualize what the question is telling you, link it to the concept. The biggest giveaway that this is the remainder is when you read the statement. Sometimes the members sit at tables with 3 members at one table and 4 members at each of the other. Right? So whatever number of tables are there, there's 4 members at all the other tables except for one where there's 3. That means Of the total people, I'm making groups of 4, and whatever I'm left out with, that's 3, I'm putting them on the last table. So that's the giveaway that this is a remainder based question. You have to understand it, okay? And harder questions will test you on how you're able to visualize the question, especially word problems, and link it to the concept that you require. So Club X has more than 10 but fewer than 40 members. Right? Not less than or equal to, should be less than, more than 10 but fewer than 40 members. Sometimes the members sit at tables with 3 members at one table and 4 members at each of the other tables. That basically means out of the total members, if I have like 20 and odd members, or let's say I have 21 members, I'm taking 4 members each, putting them on tables, and what I'm left out with, I'm putting them on the last table, right? And that last table should have 3. So when I read that statement, it's basically, when let me keep the total members of Club X as X, it basically means that when I take X and I divide it by 4, I should get groups of 4, 4, 4, 4. But finally, I'll be left with left with 3 members that I cannot distribute equally among those 4 chairs around that table. So when X is divided by 4, I'm going to get to a remainder of 3, is what the first line tells me. And sometimes they sit at tables with 3 members at one table and 5 members at each of the other tables. That means if I take the total members and make them groups of 5 and place them at the tables, I will be left with 3 members that I'll have to put on one separate table. That means when X is divided by 5, the remainder is also 3. So the best part is I don't have to worry about breaking my head on figuring out the list, because my first overlap is the 3 itself, right? So X can be 3, but what they've given me is X has to be between 10 and 40. But I've got my first number. I know it's not within the range that I require, but from the first number, I can get to all the other overlaps by adding the LCM of the divisors. So X has to be 3. It can be, the LCM of the divisors is 20. So 3 plus 20 gives me a 23. 23 plus 20 again gives me 43, and so on. But remember, I'm dealing with a range of 10 to 40 for X. So the only possible value I can consider for X is 23. So I've got to the number of members at Club X. And what does the question tell me further? If they sit at tables with 6 members at each table except one, and fewer than 6 members at that one table, that means out of the total, I'm making groups of 6, and what I'm left out with, I'm putting on one specific table. That means X when divided by 6, they are asking me what the remainder is. How many members will be at the table that has fewer than 6 members? So 23 divided by 6 should give me a remainder of 5. Echo. Again, you see, a nicely crafted question that requires you to visualize and link it to the remainder concept. Got it? Harder questions will always be of this kind. Okay. All right. Let's continue. Let's try question 9 and then go into a couple of data sufficiency ones before we go into the concept of exponents. Let's try question 9, please. Give it a shot. If you have any doubts, please put in the chat window. I will cater to them. I'm trying to solve as many questions as I can because this topic requires a lot of practice for you to get the stronghold of picking values and making a structured process and using a structured process of working. 2 minutes, your time starts now. You can start putting your answers in the chat window. Whenever you have could be question, guys, more often than not, you'll be, you will have to navigate through the answer choices. So ensure that you're patient navigating to the answer choices, right? And you're structured in your working. And remember, there's only one possible answer choice. You can't have more than one. Okay. Also, for those who are not getting an answer, type it in the chat window again. Where are you stuck? Okay. I will cater to that. There's no harm. Don't worry about what others would think of you in terms of the doubts that you ask. You've got a mixed bag of answers so far. Final call, final 30 seconds before we discuss. You can use algebra as well here for those who finished solving it. Maybe explore what the algebra process would be. Okay. Good question. It's given me a mixed bag. Some B's, some D's, some C's, some E's as well. Let's break it down. There are K workers in a division, and each worker is placed on exactly one of three teams. So K workers, let me call the three teams A, B, and C. Each worker is placed on exactly one of the three teams. So I can't have a worker working on more than one team. When the number K is divided by 3, the remainder is 1. Immediately, I will make a list of values. The first value, when K is divided by 3, that will give me a remainder 1 is 1 itself. I'm going to add 3 to it, so it's going to be 1, 4, 7, 10, 13, 16, 19, 22, and so on. These would be my possible values for K. And the questions ask me which of the following could be the number of workers on each of the three teams in terms of K. So the good thing is I've got values of K here, so I can run through possibilities. I look at answer choice alpha. Look at all the values of K. None of them are a multiple of 3. If I take 1 for K, 4 for K, 7 for K, K by 3 is never going to give me an integer, right? So I know alpha is a straightforward eliminate. Remember, the question is which of the following could be. So I just need to be able to figure out, whether it's going to hold good for one possible value for K. That's enough for me. K minus 1 by 3. If I take K is equal to 1, obviously I can't distribute one person among 3. So ideally 1 is something I don't consider. But look at 4. What if I take K as 4? If I take K as 4, they are telling me that in each of the three teams, there will be K minus 1 by 3. What is K minus 1? K minus 1 is going to be 3. 3 divided by 3 is going to be 1. 3 divided by 3 again would be 1. Since I know it's K minus 1 by 3, K minus, I'll just write it down here, K minus 1 by 3, K minus 1 by 3, and K plus 2 by 3. I'm taking K as 4. So this would give me 1, this would give me 1, 4 plus 2, 6. 6 by 3 would give me 2. So k is equal to 4 is nicely distributed as 1, 1, and 2. So it holds good for one specific value. I know I need to have one possible answer choice. At this point, I would pick B and I would move on. But let's explore the other answer choices. Let's take C. K minus 1 by 3. Now, some people picked C as well. K minus 1 by 3, K minus 1 by 3. Okay, I can pick 4, I can pick 7 for the first two. But K by 3, none of the others are going to be perfectly divisible by 3. So I know I cannot have this possible combination. Delta was another pick that was very um, prevalent. Let's see what happens. So K minus 1 means I can use K is equal to 4. I can use K is equal to 7 as well. Some people pick this, but let's see what happens. If I use K is equal to 4, then I know this is K minus 1 by 3, K minus 1 by 3, and K plus K minus 1 by 3 again. So K minus 1 by 3 is 4 minus 1, that is 3. 3 divided by 3 is 1, 1 and 1. When K is equal to 4, I have 4 people, but the values that I'm getting here is only one member in each team. So I don't cater to all the 4 people here. So I know it's not going to work. And if it's K is equal to 7, I know it's going to be K minus 1 by 3. That's going to be 2, 2, and 2, right? Which is again not going to work. So I know D would not work for me, right? Now E, K minus 2 by 3. None of the values, if I subtract 2 and I divide by 3, is going to give me an integer, right? So E is out. B would be your answer. You can use equations as well, and then you can work with it, run through your possibilities. That would be, good. You can explore that. I said, once you're working with the questions again, once you're reviewing the concepts from the video, please, in the learning phase, look at it from all aspects. Wonderful question again, right? And you see how the process works, and you see how structured I was in the working. Yeah, you can't assume that, Monica. It's nowhere have they told me that it has to be equal, right? They didn't say it's equally divided. No, I can't make that assumptions. Yeah, so D is not a possibility because when I take D, right, D is K minus 1 by 3. So I know 4 will give me an integer here. But when I take K is equal to 4, each one of them is K minus 1 by 3, K minus 1 by 3, K minus 1 by 3, right? So ideally, I have 4 people, and they are telling me that these 4 people I have to distribute by K minus 1 by 3 in team A, team B, and team C. But if I do K minus 1 by 3, 4 minus 1 by 3 is 1. 4 minus 1 by 3 is 1. 4 minus 3 is 1. So 4 people I can't distribute, right? Because here it's only distributing 3 people among those 3 teams. Right, but I have 4 people, so that person that is left out, I can't leave him, right? I mean, I just, because I've taken 4 people, and they are telling me that every value of K that I take, that those values have to be distributed among the 3 teams. So this is not going to be a possibility because 1 plus 1 plus 1 is 3, but I have 4 people. All right, that is why D is a eliminated immediately. See, as when you're working with your answer choices, as soon as you got B, no, you should have picked and moved on, because the question is a could be. You just need one possibility, and on the GMAT out of 5, you always pick one, right? So you picked and moved on. That would have been a time saver. But if you explored in your practice phase when you're exploring, D is also a good answer choice. But understand why D is wrong, because when you take K is equal to 4, I can't distribute only 3 people, right? I have to distribute all the 4 among the teams, right? All right, great. So let's move into a couple of data sufficiency as well. Right? We'll work with a power as well. This is also a very, very, very good concept. And then we'll go into data sufficiency. Let's try question 12. Then we look at a couple of data sufficiency and then look at exponents and roots. Give it a shot, please. Question 12. For people who worked the previous question and didn't get it, I also wanted you to observe how structured I was in how I set things down on my sheet, right? And how I navigated to the answer choices. That's something that you'll have to learn as well on the GMAT. Okay, the better structured you are, the way you structure your work and reason, the better you'd get your answers. Okay. You can start typing your answers in the chat window, please. Last call for answers. Very nice question. If you're able to get the concept, is very easy. If you're not able to get the concept also, I'll show you how you can reach to that conclusion. Okay. The key is to understand the concept. For those who understood the concept very quickly, you'll have got the answer because you've used the process. Those who are struggling wouldn't have got to the concept in the first place. Okay, let's discuss. For those who didn't get the answer here, or those who struggled on this question, can you all type in quickly in the chat window what you struggled with so that I can cater to that as well? Guys, quickly, for those who didn't get it, where were you struggling on this question? Oh, Nobody wants to put in their thought process. Okay. See, for those who struggled on this question, the key was for you to identify what the question is actually asking you to work. No, it's not, guys. It's not just because you see an exponent, it does not mean that I work with the units digit. Okay, it's a question. The question is not about the units digit, right? It's nothing to do with the unit digit. Just because you see an exponent does not mean units digit is always the concept that is being tested. Think about the logic behind the question first, right? What is the least possible value that can be subtracted? So 2 to the power of 586 is some large value. If I subtract something from that, it is going to give me a multiple of 7. It should be perfectly divisible by 7. So I'll just think about it logically in my mind. Okay, let me take an example. Let me take a smaller value, 2 cube. Let me take 8. If I divide 8 by 7, they're asking me what value should I subtract from 8 that will give me a result that is a multiple of 7. And you will directly tell me, if I subtract 1 from 8, what is the least possible? Remember, if I subtract 1 from 8, it will give me a value that is perfectly divisible by 7. And what is that 1? That 1 is actually the remainder when 8 is divided by 7. If I subtract the remainder from 8, it will give me a value that is perfectly divisible by 7. I want to get rid of the remainders, basically. I want the remainder to be 0. Similarly, if I take 16, 16 by 7, what value should I subtract from 16 that gives me a value that is perfectly divisible by 7? That would be 2, because 14 by 7 is perfectly divisible. So that would be the remainder. So what is the question? You see what I'm doing, right? I'm not just diving right in, seeing exponents and working with it. I'm trying to understand the question. I'm using a simpler example to figure out what does the question want from me. And now, once I have clarity on that, I would say 2 to the power of 586. I need to find out the remainder when 2 to the power of 586 is divided by 7. And once I get to the remainder of this, that I can subtract from 2 to the power of 586 to get to a number that's perfectly divisible by 7. So the question is basically asking me, what is the remainder when 2 to the power of 586 is divided by 7? And it's an exponent. We need to find the remainders. It's not the units digit divided by 7. You work with the remainder rule. So it's 2 times 2 times 2 times 2, 586 times divided by 7. If I use the remainder rule directly, it's not going to work out. So it's better for me to group terms. And I know if I group 3 2's, I'm going to get an 8. 8 divided by 7 is always going to give me a remainder 1. I want to get remainders of 1 because it's easy in terms of calculations. And I know a group of 3 2's will give me a remainder of 1. So basically, I have to figure out how many groups of 3 2's can I get in 586. So I'm just going to divide 586 by 3. 3 1s are 3. 3 9s are 27. 3 5s are 15. So I'm going to get 195 groups of 3 2's, and I'm still going to be left with 1 2 divided by 7. And I need to find the remainder of this. So I have 195 groups of 3 2's, and I know every group of 3 2's is going to give me a remainder of 1 when divided by 7. So 2 cube into 2 cube into 2 cube, 195 times into 2 divided by 7. Every one of these groups of 2 cubes will give me 1 into 1 into 1 into 1 into 1, right? So I'm going to get 1 to the power of 195 times 2 divided by 7. 1 to the power of 195 is 1. 1 into 2 times 7. That gives me a remainder of 2. And that's exactly what I have to subtract to get to my answer. Got it? Yes, Savio, that's exactly what you'll have to do. Got it? So you see what I did, right? I did not just dive right in and see, okay, it's units digit. Remember, units digit will only, the units digit here will only help when you're finding the remainder when something is divided by 5 or something is divided by 10. The question is finding out the remainder when something is divided by 7, right? What should I subtract from this such that what I'm left out with is perfectly divisible by 7. I just use a couple of examples to understand the concept. And I realize that it's the remainder I have to remove from that number for me to get to an answer. Got it? Any doubts on this? All right. Okay, we'll look at the data sufficiency question as well. And then we'll go into the concept of exponents. Okay, I'm going to pick question 15 directly for lack of time. Data sufficiency, give it a shot. Okay, you can start typing your answers in the chat window. Remember, guys, learn to break down the question on the data sufficiency. For those who looked at my data sufficiency video, you would have realized that I always endorse breaking down the question, figure out what the question's actually asking before I move into the statements. And when I'm working with the statements, I will always prove sufficiency or insufficiency. And also remember, for those who went through my data sufficiency video, If it's a yes no data sufficiency question and you're working with statements, always try to disprove, try to form counter cases, try to get a yes and a no before you eliminate. Okay, normally the mistakes test takers will make on a data sufficiency is they wouldn't break down the question stem, so they won't have clarity on what the question is asking. Second, they will not run through the possibilities with the statements. That is, in their mind, they'll decide it's sufficient or not sufficient without actually proving sufficiency or insufficiency. And second is the reverse. They will not run through possibilities to prove something as insufficient. Instead, they will directly say, oh, I'll have multiple possibilities and eliminate an answer choice. Okay, these are the three main problems that test takers face. And as if you don't get a hold on this and understand that data sufficiency requires structures, you will end up making mistakes on most questions. Okay, and you'll see most of your mistakes here for people who've given me different answers. Your mistakes will lie in one of these three zones: not breaking down the question, not running through the possibilities well and trying to disprove, and third, assuming that something is directly sufficient or insufficient without actually working for it. Last call for answers. It's a good, tough question. I told you I'll make the questions more and more harder as we go forward. It's the last question on the concept of remainders. For those not getting it, guys, I'm absolutely okay with you typing in what you struggle with on the question, right? I would definitely recommend you going through the data sufficiency video where I speak about respecting the structure, and I'm going to work the question respecting those structures that I've set up. All right, so I see a mixed bag. Statement one is enough, okay? I see a mixed bag of answers. Some B's, some A's, one A, more E's, some D's as well. Okay. So that's only around 8 answers. What about the remaining? You can also type in where you were stuck at, please. I can cater to that as well. Okay. What is the structure that I said, that I spoke about in the data sufficiency session? Spend time on the question stem. Make a note of the constraints. So I have A and B as positive integers, box it up. And the question is the remainder of 10 to the power of A plus B divided by 3 larger than the remainder of 10 to the power of B plus A divided by 3, right? This is the question. I'm not going to dive right in, right? I'm going to understand my question further. Okay, I think the logo is blocking some bit, so I'm going to rewrite this here. 10 to the power of B plus A divided by 3. Immediately when I look at this question, remember what I said in data sufficiency, try to break down the question stem wherever possible. And also try to identify what kind of data sufficiency are you dealing with. It's a yes-no data sufficiency question. That means I have to answer my question with a yes or a no before I take a call. And second, there is an opportunity for me to break down the question further because I see that it's a remainder of an addition of values on both sides of the inequality. And I know A and B are positive integers. You see how I'm putting all the pieces together. So 10 to the power of A would be a 10 or 100 or 1,000. And I know I can use the remainder rule here. What will be the remainder when 10 to the power of A is divided by 3? 10 divided by 3 will give me a remainder 1. 100 divided by 3 will give me a remainder 1. 1000 divided by 3 will also give me a remainder 1. So I can break the question down further. So 10 to the power of A divided by 3 will always give me a remainder 1. Plus the remainder when B is divided by 3, right? So the remainder of B divided by 3 that divided by 3, that addition divided by 3 is what the overall remainder will deal with. And they are asking me, is this greater than the remainder when 10 to the power of b is divided by 3? That will again give me a remainder of 1 plus a divided by 3. I want the remainder of a divided by 3. That divided by 3 would give me the overall remainder. So I know I'm breaking it down. So I don't need to worry about the 10 to the power of a. So basically now everything depends upon the remainder of b by 3 and the remainder of a by 3. Right? Everything hinges on the understanding of that. And I know it's a yes-no data sufficiency question. I have to consider, when I consider my statements, I have to think about getting counter cases, a yes case and a no case. I may have to put in some values and work, but let's see. The first statement says A is greater than B. So I'll take a couple of examples. Let me say A is equal to 2, B is equal to 1. So what does my question become? The remainder when 1 plus remainder of 1, remember B is 1 here. 1 divided by 3 gives me a remainder 1. So 1 plus 1 divided by 3 gives me a remainder 2. Is that greater than the remainder when 1 plus the remainder of A by 3? Remember, I'm taking A as 2. That's 1 plus 2 by 3 should give me a remainder 2 divided by 3. That gives me a remainder of 0. A is greater than B gives me a yes to my main question. I get a yes. Now, what should I try to do? Not go and say it is going to be sufficient. Try to prove insufficiency. I've got a yes. I need to try to get to a no. When will I get to a no? When I take B is equal to 2. Because I know if I take B is equal to 2, this will be giving me a 0. And I take A is equal to, let's say, 3. Right? So if B is equal to 2, the remainder is going to be 1 plus remainder of B by 3. 2 by 3 is going to give me a 2 divided by 3. That would give me a remainder of 0. And they're asking me, is this greater than the remainder of 1 plus 3 by 3, 1 plus 0 by 3? That will give me a remainder 1. Is remainder of 0 greater than the remainder of 1? No. So the first statement clearly is not enough. BCE. I could have actually broken down the question further, but I'm not doing that. I'm just taking a couple of possibilities. Now let's take the second. Remember, this is my question. I should not carry information over. The second says the remainder of B by 3 is 2. Now think about it, right? If the remainder of B by 3, they've given me this entire thing, they've given me the remainder of B by 3 is 2, what's going to happen to my left-hand side? It's going to be remainder of 1 plus 2 by 3. So my left-hand side is always going to give me a remainder of 0. 3 by 3 gives me a remainder of 0. This, from the second statement, makes the left-hand side always 0. Now think logically, right? If my left-hand side is always going to give me a remainder 0, what's going to happen to my right-hand side, irrespective of what value I take for A? Irrespective for what value I take for A, I know when I divide this entire number by 3, I'm either going to get 0 as a remainder, or 1 as a remainder, or 2 as a remainder, whatever value I take for A, right? So if I'm getting 0, 1, or 2, this left-hand side, since it's always a 0, will never be greater than the right-hand side. It will be equal or it will be lesser. Remember, the question is asking me, is the remainder of 0 greater than the remainder when 1 plus remainder of A by 3 is divided by 3? I know whatever value, I can take any value I want for A. Whatever value I take for A, this entire expression of 1 plus the remainder of A by 3 will only give me these 3 possibilities as a remainder. And this will always answer my question with a definite no. And a definite no is sufficient for me to work. B. The second statement is enough. This is how questions are going to be at really high levels. It will test you on your understanding of the concept. It will also test you on how you respect the format of a data sufficiency question, right? Is it good to assume value A and B and then solve the problem without breaking it down and coming to a conclusion for the answer? You can, but it's going to be a lot more working for you. You'll have to work with the 10 to the power of A as well. You can do that, Ansh, but I normally suggest that whenever you have an option to break down the question stem, right, and get rid of certain variables, get rid of certain, working, I would always take that option. You can always, stop here if you want in the question, not break it down further and directly go into the statements. But that's something I don't recommend, because when you have the option to simplify, I always take the option and simplify. All right. So guys, you see what skill sets you require at harder levels, right? You'll have to have a very in-depth knowledge of the concept. You had to hear, respect the rules of a data sufficiency, how to solve data sufficiency question. You had to identify that you could have break down the question stem by using the remainder rule. You could have simplified the question, understood what the question's asking, and then moved in to the statements. And you had to keep in mind that it's a yes no data sufficiency question. So when I may have to put in values, I would want to try to form counter cases. I would want to try to put a value that gives me a yes, and then try to find a counter case that gives me a no. In the second statement, when I tried to do that, when I got the left hand side to always give me a remainder 0, I asked myself, what would the right hand side give me? And I know the right hand side would either give me a 0, 1, or 2. A remainder 0 will not be greater than 0, right? So that will answer my question with a no. Even if the right hand side had a remainder of 1, it would still give me a no. Even the right hand side had a remainder of 2, it would still give me a no. And that's a definite no. And many of y'all who picked E as an answer did not bother to actually answer the question with a yes or a no with the second statement. You just assumed that I don't have anything about A, so it's insufficient. You eliminated that and you moved forward. That's why I said, guys, it's very important for you to understand the format of a data sufficiency question and stay within those limitations. You have to respect the format and work. Got it? So this is what I had for the concept of remainders. I have a small bit also. I think lots of people are asked about exponents and roots, so I have some guidelines for that. We'll work with some questions as well, and then we'll wrap up. It just take me another maybe half an hour to 45 minutes. So before we move forward, any last doubts on the remainder concept before we move to the exponent bit? I've basically put everything that can be tested on the GMAT instead. In fact, I've given you certain things extra as well, which I should have not, but that's more than enough for you to work with any typical GMAT question. Okay, the guidelines and the properties that I've given you. Any doubts here? Did you understand how important the format, respecting the format of a data sufficiency is, right? Most of y'all made mistakes. Some of y'all did not break down the question stem. Some of y'all did not take counter cases for the first statement. Most of y'all just eliminated the second statement because you said B is given, A is not given, insufficient. Y'all didn't run through the possibilities and then answer the question with a yes or a no. A yes-no question requires you to answer the question with a yes or a no before you take a call on whether something is sufficient or not. Yeah. Guys, I'll be taking another maybe half an hour to 45 minutes to speak about exponents. If you feel that it's been a long day, log out, and then you can always look at the recording. But when you log out, please like the video and move forward. Right? So can we go forward? One more DF is possible. No, Adil, I think I have the. I will give you the PDF. So in that there are another 2 data sufficiency questions as well. Right, I will give you explanations of that as well. So we can work with it once the session is done. Okay. All right. Sessions are done once every 3 to 4 weeks, Harsh. Okay. I mean, I would always break down a question when I see an opportunity to do so. Toss, if there's nothing for me to identify there, right? I mean, immediately when you see a remainder of, if someone gives me the remainder of 15 plus 15, it's just that these two are in terms of algebra, no? So when I see 15 by 15 divided by 7, when I see it in that form, immediately I will choose to break it down further, right? It's all about pattern identification, right? It's about you recognizing those patterns, linking it to the concepts, and then using those concepts to break down. Okay, there's no special skill set that I'm using to work with. I'm just working with the question, looking at the format of the question, linking it to the concepts that I've learned, and then breaking it down further. Breaking it down always helps. It makes your working easier. Okay. All right. So let's move to the last bit. I'm going to toggle to my sketchbook. Let me know once you're able to see it. Yes. Exponents and roots. You will definitely get some questions that deals with exponents, that deals with working with roots, that deals with working with decimals, that deals with approximation on the test. Okay, you will definitely get a couple of questions that work on that concept. I'm going to deal with exponents and roots here, since it's a part of number properties. Approximations and decimals, I think most of you are okay with, and I think most test takers find the exponents bit a little more difficult, and this concept of exponents even carries forward towards the concept of prime factorization. You may have to use exponent manipulations with compound interest questions as well, because compound interest boils down to an exponent working in addition to you knowing the formula. So it has a lot of carryover. Okay, and roots are also, you get straightforward root questions as well, where they deal with simplification of roots. I'm going to put some guidelines. Most of y'all will know the rules of exponents. I'm sure all of y'all will rote learn the rules of exponents and work. But it's not about the rules, okay? It's about setting up an exponent question so that you can make use of the rules in the most efficient way. So what are exponents? Exponents are, um, you can have integer exponents, you can have fractional exponents. But when I say 7 square, right, what does that mean? You're taking the same number and multiplying it by itself. So an exponent is how many times that base is multiplied by itself. And if I have a fractional exponent, 7 to the power of half is what we refer to as root 7. These are what we call roots. So roots are basically fractional exponents, right? These are integer exponents. Whether they are roots, that is fractional exponents, or whether they are integer exponents, all exponents will always follow and adhere to the rules of exponents. You have to know and respect the rules of exponents. So let me list out the rules first. Most of you all will know it. I'm still doing it. So the first rule, what is a to the power of m times a to the power of n? That's a to the power of m plus n. You don't need to rote learn it, guys, right? So whenever I have some formula, this is how I've learned. Always take examples and work with it. So if I have 2 cube into 2 square, that's 8 times 4, which is 32. And I know 32 is 2 to the power of 5, right? If I prime factorize it. So you see, the powers add up, right? Second, a to the power of m divided by a to the power of n is a to the power of m minus n, right? So again, take an example to understand it. 2 to the power of 5 divided by 2 cube. Let's say I have 32 divided by 8 gives me 4. 4 is a 2 square. And you see that the 2 is obtained by subtracting the exponents. That's the second property. Third, a to the power of m whole to the power of n is a to the power of mn, right? For example, 2 cube whole square. What does a whole square term mean? You're multiplying the same term by itself. So that's 2 cube times 2 cube. And 2 cube times 2 cube using the first property is 2 to the power of 3 plus 3, which is 6. That basically boils down to a multiplication of the exponents, right? That's how you get that. Fourth, AB to the power of m is a to the power of m, b to the power of m. Again, if I take an example, 2 into 3 to the power of 2, that boils down to 6 square, which is 36. And if I prime factorize 6 square, I'm going to get 2 square into 3 square, which is exactly the same as you taking the powers on each of these terms, right? Fifth, a to the power of 0 is 1. Anything you raise to the power of 0 except 0, right? Any other positive or negative integer you raise to the power of 0 will always give you 1. Now, 100%, most of you all would have just wrote learned this. I'll show it to you why it is 1. So a to the power of 0, why is it 1? I'm writing a to the power of 0. I'm just being smart with it, okay? And this is how, again, you remember concepts by understanding the why of things. So a to the power of 0 is a to the power of 2 minus 2. I can write 0 as 2 minus 2, or 3 minus 3, or 4 minus 4. And this now boils down to this second property, right? A to the power of m minus n is a to the power of m divided by a to the power of n. So remember, the exponent rules work both ways. So I can write that as a square by a square. That would cancel to give me 1. That is why a to the power of 0 is 1. Okay, don't rote learn it, please. And last, a to the power of minus m is 1 by a to the power of m. Again, you would have rote learned this. In school, they would have told you, just mug it up, right? I'm going to show you why. A to the power of m is 1 by a to the power minus m is 1 by a to the power of m. Simple. I can write minus m as 0 minus m. I'm just using what I know, right? And this is again in the form of a to the power of m minus n. So this will be a to the power of 0 divided by a to the power of m. A to the power of 0 we've already established is 1. So a to the power of minus m is 1 by a to the power of m, right? So I've written the rules of exponents, but you see how I've learned it, right? I've not learned it and as a rote learned process of working. I've understood the why of each of the exponent rules. 100%. All 30 of you all who are in the session now know these exponent rules. If you don't, you know it now. Okay. But when you're working with exponents, no, it's similar to working with algebra. Knowing the algebra rules and the formula of a plus b whole square, a square minus b square is only one aspect. The second aspect is, how do I set up my equation so that I can make use of the algebra patterns or the exponent rules that I know? And that's what most test takers don't do in an exponent based question. They don't focus on setting up the exponent equation so that it's conducive to make use of that rules. In addition to these rules of exponents, it's important for you to understand certain guidelines. These guidelines, if you understand, you'll be able to use those rules really efficiently. Okay, and you'll be able to figure out what needs to be done on a question as well. What are these guidelines? What do they help you out with? They always help you set up an exponent equation such that it is conducive to the use of the rules of exponents. If you focus on setting things up well and understand these guidelines, you'll be able to use your rules in a much better way. So what are these guidelines? Let's list them out one by one. First, I'm just not randomly going to write the guidelines. You'll understand how logical the guidelines are and how I use my rules of exponents to write those guidelines. I want all of y'all to observe these 6 rules that we've written down, especially the left-hand side of all of the 6 rules. Each and every one of your exponent rule, the left-hand sides, dealt with multiplication or division. There was no exponent rule for adding exponents and subtracting exponents. There's absolutely no exponent rules for e to the power of m plus e to the power of n, or e to the power of m minus e to the power of n. Absolutely no exponent rules. All your exponent rules deal with multiplication and division. So what should that tell you? That should tell you that when I'm working with exponents, for me to make use of the rules in a much better way, it's better for me to convert addition and subtraction. Whenever I have additions and subtractions with exponents, convert it to multiplication and division. Always learn to convert addition and subtraction to multiplication and division. Why? Because there are no exponent rules that deals with an addition or a subtraction of exponents. Now, how do you do this? How do you convert addition and subtraction to multiplication and division? So whenever I have something like 4 to the power of t plus 2, if somebody gives me an exponent like that, I'll not just take it and start doing my calculation. I told you, I will try to get rid of additions and subtractions wherever they are when I'm dealing with exponents, whether they are in the power or whether they are between two terms or three terms. I will try to get rid of it. So what I would do, the first step I would do is I would use the guideline and I would write this as 4 to the power of t into 4 square. You will be served better when you put that as multiplication. Okay, why? Because you'll be able to use the rules in a much better way. So how do I convert addition and subtraction to multiplication division? Here, when you have additions and subtractions on the powers, it's very easy for you to use the exponent rules and convert it to multiplication and division. Trust me, converting to multiplication division makes things easier. How else can you convert things from addition and subtraction to multiplication division? By factoring out common terms. By factoring out common terms, I can always convert addition, subtraction to multiplication and division. For example, if I have 3 to the power of a plus 3 to the power of a plus 3 to the power of a, I will not leave it as it is. What is common between these three? 3 to the power of a. It will be 1 plus 1 plus 1. So I see some people taking a base out common. They'll take 3 out common and say 1 to the power of a, 1 to the power of a, 1 to the power of a. Guys, you can't make up your own rules here. You can't take a base out common like that. It's like me saying 2 cube plus 2 square. I'll take 2 out common and that will be a 1 cube plus 1 square. Right? Clearly 2 cube plus 2 square is 8 plus 4, 12. Right? You're boiling it down to 2 into 1 plus 1, which is 4. That's not correct. So never take only bases common, okay? A base and a power comes as an entire term. So you take an entire term out common. So you say I'm taking the 3 to the power of a out common. So 3 to the power of a, 1 plus 1 plus 1 is 3. And now I can write this as 3 to the power of a plus 1. You see, I've boiled it down to this format that I want. So one way of converting addition and subtraction to multiplication and division is to factor out common terms. Another example would be if I give you something like this, 3 to the power of a plus 3 to the power of a minus 2. What do you think would be the simplest way for me to simplify this? Right? I want you all to tell me quickly in the chat window. What do you think would be the best way to simplify this? You can go along a roundabout process. You can get the answer in one step as well. So what do you think would be the best way for me to simplify this? Factor out 3 to the power of a minus 2. Yes. Right? Factor out 3 to the power of a minus 2. That would be the best way, because now look at it, right? Normally when you have a 2 cube and a 2 square, you always factor out the lower term. You factor out the 2 square and you say that's 2 plus 1. That's the same way what you do here. Take 3 to the power of a minus 2 common. And if you take 3 to the power of a minus 2 common, I should figure out what should I multiply 3 to the power of a minus 2 by to get 3 to the power of a, and that would be 3 square plus 1, because the 2 and the minus 2 would cancel out, right? If I multiply this back in, if I FOIL it, 3 to the power of a minus 2 into 3 square would be 3 to the power of a plus 1, right? So 3 to the power of a minus 2 into 10 is what you would get here. This would be the fastest way. Even for people who are not able to do this, you're not able to intuitively, take the 3 to the power of a minus 2 and then figure out that that's 3 square, no problem. Follow the guidelines like what I told you, right? Change this into a division, right? Get rid of that addition or subtraction on the exponent. Now I see 3 to the power of a common. I can do 1 plus 1 by 3 square. Now I can simplify what is in the bracket. That's 3 square plus 1 by taking the LCM by 3 square. So that's 3 to the power of a divided by 3 to the power of 2. That's 3 to the power of a minus 2. 3 square plus 1 is 10. So it takes you another couple of steps extra, but it gives you the same answer. So the first way of converting addition and subtraction to multiplication and division is to factor out common terms. Second way of converting addition and subtraction to multiplication and division is to identify a square. Yes, you can factor out 3 to the power of a as well, but it's better to factor out 3 to the power of a minus 2. Identify a square minus b square patterns. Identify a square minus b square patterns. Because a square minus b square boils down to a difference of squares. So if you get something like 3 to the power of 8 minus 2 to the power of 8, you may get such expressions in prime factors, or some expressions like this in arithmetic or number properties. You should be able to identify that as a difference of squares. Remember, the a square minus b square, the difference of squares, works for a difference of two powers which are also even, right? So immediately I have to identify that this can be broken down as an a square minus b square. Maybe the question can be, what is the greatest prime factor of 3 to the power of 8 minus 2 to the power of 8, right? So you'll have to identify these patterns. What will I do? This is in the form of a square minus b square. So 3 to the power of 4 minus 2 to the power of 4 into 3 to the power of 4 plus 2 to the power of 4, right? And this again is in the form of a square minus b square. 3 square minus 2 square, 3 square plus 2 square, 3 to the power of 4 plus 2 to the power of 4. And again, this is in the form of a square minus b square. So 3 minus 2 into 3 plus 2 into 3 square plus 2 square into 3 to the power of 4 plus 2 to the power of 4. So you see, you've broken this subtraction into a product. That's 1 times 5. 9 plus 4 is 13. 3 to the power of 4 is 81. 81 plus 2 to the power of 4 is 16. That's 97. Prime factored, right? 97 is definitely prime. So you see, you're going to get things like this. They'll ask you to, prime factorize such a number. So at that point, you'll have to identify those a square minus b square patterns. And third, whenever you have a continuous string of nines or zeros, whenever you have numbers, right, where you have continuous strings of nines or zeros, those kinds of numbers, whether they are decimals or whether they are integers, those kinds of numbers where you have continuous strings of nines or zeros, that's an indicator to you that it's better for you to represent. You'll be better served to represent the number in its power 10 form. In its power 10 form. For example, if someone gives me 9919, or if someone gives me a decimal 0.9991, you see, whenever I see continuous strings of nines or continuous strings of zeros, that should always be an indicator. And this carries forward. This what I'm speaking here carries forward in other topics on numbers as well, when you work with decimals as well. When you need to find the number of zeros, the number of non-zero elements in a decimal. So when you have continuous strings of nines and zeros represented as a power 10 form. So what will I write this as? I will write this as 10,000 minus 81. because doing that will help me. They'll design the number in such a way that they give you an opportunity to break down. So this is 10 to the power of 4. 81 is 3 to the power of 4. And again, it boils down to an a square minus b square pattern. So that's 10 square minus 3 square, 10 square plus 3 square. That's 10 minus 3, 10 plus 3 into 10 square plus 3 square. So that's 7 into 13 into 109. That would be 9919. So when you see continuous strings of nines or continuous strings of zeros, change it into its power 10 form. Even if it's a decimal, right? Even if it's a decimal, you write this as 1. A power 10, 10 to the power of 0 is 1. So 1 minus 0.0009. 1 is 10 to the power of 0 minus 9 into 10 to the power of minus 4. You see, I'm writing it as in a power 10 form. And again, this is in the form of a square minus b square, right? 9 is a perfect square. This also has an even exponent. So I can write it as 1 plus 3 into 10 to the power of minus 2 into 1 minus 3 into 10 to the power of minus 2. This is how you use continuous strings of nines and zeros to your advantage. Okay, so if you want to convert addition and subtraction to multiplication and division, these would be the guidelines that you follow. That's the first. You see what I'm doing? My focus is not on the rules. Rules come in a secondary sort of way. My focus is first setting up my exponent equation so that I can make use of my rules in the most efficient way. And trust me, all questions and exponents, if you focus on the setup, you choose the right approach to break it down, you'll be able to use the rules of exponents very easily. So that's the first guideline. Second, again, I want all of you to observe the left hand sides of all the rules that we've listed out. Look at what you can observe. All your exponent rules held good when the bases were the same. Look at 1, look at 2, look at 3, look at 5, look at 6. All the bases are the same. But where the bases were not the same, the powers were the same. So what does that mean? That whenever you're working with exponents, you should always try to keep the bases the same. Try to manipulate your exponents in such a way to try to keep the bases the same. If you're not able to keep the bases the same, no problem. Or keep the powers the same. Because if you're able to keep the bases the same or you're able to make the powers the same, you will be again able to use the rules of exponents to your advantage. Right? So if you have something like 2 to the power of t plus 1 is equal to 4 to the power of x, keep the bases the same. They will help you equate the powers efficiently. So now I can say that 2x is equal to t plus 1. If you're not able to keep the keep the bases the same, keep the powers the same. Keeping the bases the same, no? Keeping the bases the same will help you simplify and equate exponents. But keeping the powers the same, there's an application to it. Keeping the powers the same will always help you compare different exponents with each other. So whenever I see a question that asks me, that gives me a set of exponents and asks me to arrange exponents in ascending or descending order, or it asks me to directly compare exponents, I will always try and make the powers the same. Let's take an example, right? Let's take 2 to the power of 24 and 3 to the power of 16. If I give you these two numbers and I ask you to tell me out of these two quantities, which quantity is bigger and which quantity is smaller. Now I see that the bases are both different here. They are primes as well. I can't break them down further. So what should I do? I should try to make the powers the same. If I can't do anything with the bases, powers is what I want to deal with. So I see 24 and 16. So the question I'm going to ask myself, what is the biggest common factor of 24 and 16? That's 8. So I can rewrite this as 2 cube to the power of 8. And I can rewrite this as 3 square to the power of 8. So now once I make the powers the same, the one with the bigger base will always be the bigger value. That's 8 to the power of 8 and 9 to the power of 8. And clearly 9 to the power of 8 is bigger than 8 to the power of 8. That makes 3 to the power of 16 the bigger exponent. So there's an application, right, of making the powers the same. When you need to compare exponents, try to keep the powers the same always. Got it? So the second very important guideline, when you're working with exponents, always try to keep the bases the same or keep the powers the same. Third, fourth are like pointers of sorts. Okay. Third, I see many people making mistakes, so I'm adding these pointers as well. There is a big difference between 2 cube whole square and 2 to the power of 3 to the power of 2. Both of them are not the same. 2 cube whole square is basically 2 cube times 2 cube. It basically boils down to the third of the exponent rules. That would be 2 to the power of 6. But when you have a base raised to a power and that also raised to a power, 2 cube whole square. That means this is 2 cube whole square. This is 2 to the power of 3 and that's 3 to the power of 2. So first of all, it's different from what I've written in the first case. And second, what is 2 to the power of 3 to the power of 2? Some people write it as 8 square. 8 square, you'll realize, will boil down to 2 to the power of 6. It's not. You always work for the exponent first. So the 3 square is 9. So this would be 2 to the power of 9. So remember, a to the power of m whole to the power of n is not the same as a to the power of n, m to the power of n. Okay, they are two different possibilities. When you have a base raised to a power, that raised to a power, you always work for the power first and bring it onto the base. So 2 to the power of 3 to the power of 2 is 2 to the power of 9. Keep that in mind. I see mistakes happen, when you have numbers like that. Fourth, again, where mistakes happen with exponents is when negative bases are involved. Minus 2 whole square and minus 2 square, they don't give you the same outputs. Here the minus is within the brackets, so that is also going to be squared. So this is minus 2 times minus 2. But here the power only applies onto the 2. There's a big difference between representing the numbers, like this as opposed to this. So what I do, right, to avoid the confusion, especially when I have negative bases, I try to isolate the negative quantity. Right? Isolate the negative to avoid confusion. Isolate the negative quantity to avoid confusion. You'll understand it better as well. You can work with it if you're good with exponents, but if you make mistakes, it's better for you to write down minus 2 as minus 1 into 2 whole square, and better you write minus 2 as minus 1 into 2 square. You see, I'm getting rid. A negative sign means that term is multiplied by minus 1, right? So I'm putting this out here, right? And now I can work with it. Minus 1 into 2 whole square would be in the form of the fourth rule. That's ab to the power of m. That's a to the power of m times b to the power of m. Minus 1 whole square is 1. 1 into 4 is 4. Here, minus 1 into 2 square is 4. Minus 1 into 4 is minus 4. So you see, both of them give me two completely different values. So be a little careful when you have negative bases. If you're getting confused, isolate it. Right? When you isolate the negative one and work with it, your confusions get negated. All right. And the last of the exponent rules, exponent guidelines. Right? Like I said, roots are also fractional exponents. So they should also respect the rules of exponents. So when you work with roots, don't look at roots as a completely different ball game altogether, right? They are just fractional exponents. So if I give you root 2 into root 3, it's actually 2 to the power of half into 3 to the power of half. You see the powers are the same. So I can use the fourth property. So that will be 2 into 3 to the power of half, which is 6 to the power of half, and 6 to the power of half is root 6. That's how you get root 2 into root 3 is root 6. Root 2 plus root 3, you can't do anything. You have to add the numbers individually because they are exponents again, and there's no property for additions and subtractions. So remember, when you work with roots, you still have to follow the rules of exponents. But with roots, right, you'll have to know how to simplify roots. So if I give you a root of 96 and you're asked to simplify the root of 96, the best way to simplify roots quickly is to prime factorize, or not prime factorize, is to factorize this into two quantities where one is a perfect square. Obviously, if you can't do that in your mind, you can prime factorize and write it in terms of powers and then simplify. But if you're good with multiplication, 96 is 16 times 6. I'm always going to write that number as a product of numbers where one number is a perfect square, right? So 16 I know is a perfect square. I can take it outside. That would be 4 root 6, right? Same with maybe a root of, let's say, 240, right? So looking at this, I know I can break this down as 4 times 60. If you're not able to think about the exact values, I know looking at it, I know 16 times tables, so that will work out here as well. But if you're not able to figure that out, no problem. So 4 into 60 is what you can know. You can definitely work with because 24 is 4 times 6. So that will give me 2 root 60. And root 60, again, I can break it down as what? What do you think I can break down 60 further? 15 times 4, right? That's a perfect square again. So I can take the 2 outside. So it'll be 2 into 2 into root 15. That'll be 4 root 15. If you know 16 times tables, 16 into 15 is 240, and that would work. But if you're not comfortable with this, go ahead and prime factorize it, put it in terms of exponents, and then pull out the even power terms outside, right? But there's one more thing that you have to keep in mind when you're working with roots. When you're working with roots, this is a mathematical structure of working. We never leave a root expression on the denominator. Okay. I see many test takers at some questions, they get to the last stage, but then they see that their answer is not there in the answer choices. And they've got a root in the denominator, but the answer choices don't have any. Correct? So you never leave a root in the denominator. You always rationalize roots. Okay, it's very important for you to understand this, that when you're working with roots, it's always better for you to rationalize them. So if you get something, if you're working with questions and you get to 1 by root 2, don't leave it as it is. Your answer will always be in a rationalized form. So rationalization basically means getting rid of a root term in the denominator. So what do I do to rationalize this expression? Since I have only a single root in the denominator, I'm going to multiply and divide by that same denominator. It's not going to change the value. So this will be root 2 divided by root 2 into 2. Root 2 is 2. Your answer will be in this form. Now, what if you have an addition or a subtraction of roots in the denominator? Then here also we rationalize it, but we rationalize it by multiplying and dividing by its conjugate. Basically, conjugate means it's the opposite sign of what terms you have on your denominator. The reason we do that is because if we multiply the denominator by root 3 plus root 2, it would be in the form of a minus b and a plus b, and it's a square minus b square. So you can get rid of the root terms on both the quantities. So into root 3 plus root 2 over root 3 plus root 2. So that will be root 3 plus root 2 divided by a minus b times a plus b is a square minus b square. That's 3 minus 2. That's 1. That will give me root 3 plus root 2. So remember, when you're working with roots, always rationalize the roots. And I also mentioned this when we worked with the topic of algebra. If you've not seen that, I would encourage you to go and see the algebra session. There's a lot of overlaps that you'll find here with roots and exponents. When you have an equation in algebra where there is a root expression or there's a root term, it's always best for you to get rid of roots. Okay, by squaring or by factoring, always learn to get rid of roots whenever you see expressions with roots involved. Correct? So these guidelines are going to be super critical when it comes to solving questions, because if you set up the question well, you will be able to use the rules of exponents well. All right. Any doubts on this? We'll work with a couple of questions and then we'll wrap up. Any doubts in what I spoke about? The guidelines, I've listed out the rules as well. Any doubts, please ask me at this point. Okay. So let's look at a couple of questions. Shifting to the PPT. Let's try question 18. Like I said, you will get questions where simplification is required. Give it a shot. I'll give all of you all a couple of minutes. Follow the guidelines, guys. Right? Start small. Get rid of the addition, get rid of the subtractions on the powers. Right? Simplify. Then try to get rid of the addition between the two terms that you have. Okay, you can start typing your answers in the chat window, please. I can understand if you're also tired. I'm also knackered a little bit. It's the last phase. Let's work with it. Only one answer so far. Okay, for those who are stuck, can you type in the chat window where you're stuck? If you're tired, you can type in tired as well. We'll work with one more question, and then, you know, once the guidelines are set, you go look at the video once again. I think with a fresh mind, working with the questions would make more sense. I think there's around 20 questions in the worksheet, so done around 14 of them, if I'm not wrong. So you can try the remaining 6 later. But I definitely recommend going through the video again, guys, and making your notes, taking screenshots of whatever I write on the screen, taking a printout, keeping it with you, however you like to make notes. Stuck at 4. You got 4 to the power of mn minus 1. Okay, so this is normally what happens, when you don't respect, the guidelines. You make it overcomplicated. So the guidelines always simplify things for you. Okay, I want you to see how I'm going to use my guidelines on this question. So when I observe the question, I see, okay, m is not equal to minus n. That's given to me. And I see when I work with exponents, I see there's a subtraction on the power. I ideally want to get rid of it. And I also see that I have two exponent terms which are added to each other. I would want to try to get rid of that addition as well. So what would I do? I'll start small. I'll try to get rid of these. 2 divided by 2 to the power of m divided by 2 to the power of n minus 1 plus 2 divided by 2 to the power of n minus 2 to the power of m minus 1. Worst case scenario, you could have just put values as well and run through the answer choices. It'll be difficult, but that's also a possibility if you get stuck. Not a good option though. But you see what I'm doing? I'm using the rules of exponents step by step. I want to get rid of that subtraction on the power. So I can take the LCM here. So the LCM would be 2 to the power of n, and that 2 to the power of n would go on top. So 2 times, actually let me do the steps. Not everybody would get that directly. So 2 divided by 2 to the power of m minus 2 to the power of n divided by 2 to the power of n plus 2 divided by 2 to the power of n minus 2 to the power of m divided by 2 to the power of m. Right? I'll take the 2 to the power of n on top. So 2 into 2 to the power of n divided by 2 to the power of m minus 2 to the power of n plus 2 into 2 to the power of m divided by 2 to the power of n minus 2 to the power of m. I've simplified that, right? Now, pausing and observing and running through the guidelines in your head is a very, very important skill set when working with arithmetic and working with algebra. Pausing, observing, and adhering to the guidelines. So what do I observe here? I see I have an exponent term, I have another exponent term, there's an addition to it. I want to get rid of it. I want to make it across a common base, and I want to make it either a multiplication or a division, right? So what do I observe? If I have a common denominator, I can easily add them up. I can add the numerators, but here the denominators are not the same. But I observe that they are reverses of each other. You see, one is the negative of the other. So I can rewrite this. I can rewrite this as 2 into 2 to the power of n divided by 2 to the power of m minus 2 to the power of n. And I can multiply the second term by minus 1, change the plus to minus 2 into 2 to the power of m divided by 2 to the power of m minus 2 to the power of n. Now, that gives me the opportunity to change this entire subtraction of exponents to a division. That's 2 to the power of m minus 2 to the power of n, and 2 into 2 to the power of m minus 2 into 2 to the power of m. And here as well, I have a subtraction of exponents. I want to take things common. So I'll take 2 common, 2 to the power of n minus 2 to the power of m divided by 2 to the power of m minus 2 to the power of n. I see here they are again reverses of each other, so I can pull out a minus 1 common. So minus 2 to the power of m minus 2 to the power of n divided by 2 to the power of m minus 2 to the power of n. Now I can cancel this out. That gives me minus 2. This is why I said that the guidelines are very important. Okay? The problem with these kinds of questions, you'll definitely get one or two of them, is that if you're not adhering to guidelines, you can make the question overcomplicated for yourself. Got it? So what were the guidelines that I used? Whenever I saw an addition or a subtraction, I got rid of it by converting it to multiplication and division. So there was an addition or subtraction of the powers, plus the individual terms also had an addition. So I tried to get rid of that as well. So see, I adhered to the guidelines at every stage and I simplified. Also, if you noticed, I didn't just blindly work. I observed, I paused and I observed the equation so that I can make the best possible decision going forward. Make sense? And you see, I also tried to keep the bases the same everywhere. I didn't make it as 4 at any point. All right. So Samiran, you did not look at this pause and observe that one was the negative of the other, right? So if you had done that step and changed it to negative, your answer would have come in very quickly. Yes. All right. So this is why the guidelines are very, very important. All right. Let's try one more. Two more, and then let's move forward. Okay. Let's try question 17, please. Again, 2 minutes. And then we'll move on to a last question. We'll work with it. Follow the guidelines, guys, and be patient with things. Normally, there's a high chance you make silly mistakes on these kinds of questions. So that's why I've put those guidelines in place. Get rid of the negative exponents first. Then when you see a negative base, isolate the negative quantity. If you follow the guidelines, right, you'll avoid making silly errors, right? I can solve this in a couple of steps because I'm very well versed with it. But the reason why I'm also giving you those guidelines is, it will help you be a little more careful. Okay. For people getting a 0, check again. These are what I call red herring questions. Okay. Look very simple, but there's a high chance of making a mistake. These kinds of questions and functions, right, are red herring questions. You have to be very careful with them. They're not difficult. Just have to be a little careful that you don't make silly mistakes. For those who got 0, check again. You're making mistakes with a negative sign. Okay, that's the big mistake you're making. Okay, let's discuss. So like I said, I'm going to follow the guidelines, right? I'm going to respect my rules of exponents as well. I see I have a negative on a base. I see I have a negative on a power, and I see I have a negative on this power as well. Let me get rid of them, right? Let me work with my guidelines. Let me get rid of the negatives on the powers first. So this will be 1 divided by minus 2 to the power of n whole square plus 1 divided by 2 to the power of n whole square. Now you understood. For people who gave me 0, you just took the minus 2 inside and then you cancelled both the terms because you got them to be equal. The minus sign, the minus 2, when it makes it plus 2, you know that this becomes a positive value. You have to be very, very, very careful. It doesn't stay negative. Now, I have a negative on the base, so I'll try to get rid of it. I'll try to isolate it. So minus 1 into 2 to the power of n whole square plus 1 divided by 2 to the power of n whole square. So 1 divided by minus 1 square into 2 to the power of n square plus 1 divided by 2 to the power of n whole square. Now it's become easy. 1 divided by minus 1 square is 1. 2 to the power of n whole square is 2 to the power of 2n. So 1 into 2 to the power of 2n plus 1 square is 1. 2 to the power of n whole square is 2 to the power of 2n. I see that it's the two same terms. So I can write this as the denominators are the same. I can just add the numerators. So it's 2 divided by 2 to the power of 2n. That's 2 to the power of 1, remember. That's 2 to the power of 1 minus 2n. That should be my answer. Not A, not B, not C. 2 to the power of 1 minus 2n. That would be D. That's my answer. So you see, again, I respected the rules and I worked with it. The reason why I chose exponents as well, I know I wanted to keep the session entirely with remainders because it's an important concept and most people struggle with that. But I see a lot of test takers, especially on the focus edition, making a lot of mistakes on questions that relate to functions and exponents and roots, right? Because they rush through and they don't respect certain guidelines. And the answer choices are also designed in such a way that if you make a mistake, you'll end up picking that answer choice. So you see, for people, Harsh, Akhilesh, Chandrasekhar, you corrected it. You saw what your mistake was and why you had to be a little careful with the negative sign. You see, I didn't try to do 2 or 3 steps together in one step, right? I got rid of the negative exponent. I saw there was a negative base. I isolated it and I worked with it. And then see, I avoided all those pitfalls and I finally got to my answer. When you're working with function-based questions and exponent and root questions, right, you have to be very, very careful, right? Slow down a bit, follow the guidelines, do the working slowly. The answer will come in together. But if you rush through, you'll pick a wrong answer choice. And remember, the quant section is if you're penalized a lot for a couple of silly mistakes. All right. So that's what I have for the day, right? I'm also a little tired. I had around 20 questions, so I will upload the PDF by tomorrow, day after. The questions that I have not taken in during the session, I will draft explanations to it. What I always suggest is go through the video again, make your notes, and then give a shot at each of the questions again. Like I also mentioned throughout the discussion on remainders, explore the algebra process as well. It makes your understanding of the concept a lot more sound. Got it? I was today years old when I found out why a raised to 0 is 1. All right. Yes, I know. I know many people, rote learn it, right? I was lucky that way that I was given an education which dealt always with questioning, right? So I hope also, the way I break things down, The way I deal with concepts also encourages you to learn math that way, because that's the most, I would say, exciting way to learn math, understanding the why, and it gives you a really in-depth understanding of things. All right. So the guidelines that I give you in each of the sessions are based on my learnings, and my notes that I used to make when I was preparing, especially on specific topics, right? So I'm happy to share them with you. All right. And I have another 5 minutes to do any questions. You can ask me this. um, all right, my next session, it's going to be maybe 3 or 4 weeks time. I will take the time and work. A lot of people have asked me for a time and work session, so I will do it. And the last session, I will keep it open at this point, for any more suggestions. I'll take the last session. I have 8 sessions, in total. This is the sixth, so 2 more, and I hope all the pain point topics are taken care of. Right. All right. Any questions, guys? Thank you for all your kind words. Right. I hope the videos are helping. The purpose of the videos is why I do it completely, as a 4 hour session, is because I want to put things out there, so you don't have to go into purchasing too many courses if you can't afford it, and taking up personal tutoring if you can't afford it. You can do self prep as well. Okay, things have become too costly nowadays, so I hope the videos help. Okay. The simple difference between the two, Rohan, it's like an oxymoron, right? The highest common factor is the lowest power of the primes that are common, right? What is important on HCF is commonality as well. And the LCM, lowest common multiple, is the highest power. Just remember it as a kind of, opposite of sorts, right? Highest power of all the primes. Okay, that's the difference. In HCF, it's always the lowest power. Highest common factor is always the lowest power of the primes that are common. And LCM is the highest power of all the primes. All right. So highest common factor, take the lowest powers of the primes that are common. Lowest common multiple, take the highest power of all the primes that you have. Okay, Rohan? That's the fastest I can explain that, right? If you want an example, if I take 24 and 36, 24 is 2 cube into 3, 36 is 2 square into 3 square, right? So if you're taking the HCF, it's the lowest power of all the primes that are common. 2 and 3 are common. The lowest power is 2 square and 3. So the HCF is 2 square and 3. The LCM is the highest power. That's 2 cube into 3 square. And there's a property as well, just an add on quickly. Whenever you're finding the HCF and LCM of two numbers, the product of the HCF and the LCM will always be equal to the product of the two numbers. Okay, that's a property of the HCF and LCM as well. All right. Any other questions before we wrap up? Before leaving, guys, don't forget to put a like on the use the like button, and let's make this video more accessible to people out there, right? Any suggestions of preparation 2 weeks before the test? Ideally, you shouldn't do any preparations in terms of learning concepts, Atul. The only thing that you'll have to do in a cyclical process is to work with timed practice sets, analyze those practice sets, do a SWOT analysis of sorts, find your strengths, weaknesses, opportunities, threats, take up a practice test. Normally, people only focus on the weaknesses, but I always suggest to focus on the opportunities and threats. Opportunities are basically questions that you've got right, but have taken you a long time to solve. Those are the ones, if you fix, you're able to push that score by another 1 or 2 points. And the threats are the common, the silly mistakes that you make, right? If you're able to work on that and fix that, you can optimize your score by another couple of points. 30 days before the test, strong verbal, embarrassing data. Data insights is tricky. Um, See, the thing, many test takers ask me, how long did you take for prep and so on, and I tell them, it wouldn't make sense for me to tell you that because I took 2 weeks of prep to take my GMAT, right? That's not because I was super at certain things and so on. It was because I've built those skill sets over time with what kind of education I've had and how I've read things and so on. So with data insights, guys, what I've also come to realize, it's how you read and process information in a specific time frame and how you work on decision making. So what I normally suggest for DI, right, is for you to learn to build that reading and processing abilities where you don't have to go back and reread things, but you're able to, in a very say um, say structured manner, read the question, jot down the information, and draw those inferences that are required. And also it's very important for you when you're working with DI to work with, don't sit and work with a set, right? The best way to work with DI, take 6 data sufficiency questions, take 3 or 4 two-part analysis, take a couple of multi-source reasoning, take a couple of table analysis, right? And work with those questions, keep working with those questions, then organize all the data and see what your accuracy are on each of the questions and what kind of time you're taking on each, right? So you'll know clearly what you need to work on, what are your strengths, what are your weaknesses. So once you're clear about that, right, if you figure out you're working with an MSR and an MSR question is taking you 9 minutes and that's causing you a bit of a heartache later because you have to rush through questions that you could have actually solved, then the smarter process of working would be to let go of the MSR in between, take that hit, work with everything that comes later, and then come back to the question towards the end, right? Yes, you might lose something in between, but the very fact that you don't lose out on continuous questions towards the end has its benefits, right? So you'll have to work on decision making and you'll have to work on practice and reading and processing, okay, with the data insight section. So focus on building those skill sets, okay? That's something that I normally recommend to test takers, okay? Planning retake Q82 with 5 wrong, miss 3 from algebra. How do I approach? Start again? No, I don't think you'll have to start again, Sivadas. It's about identifying what kinds of mistakes you make on arithmetic and algebra. Okay, so if it's a mistake, most of the mistakes in arithmetic and algebra would be you making a silly mistake, you missing out a corner case that you should have considered. So try to work with questions on algebra and arithmetic and see what kinds of mistakes you're making, right? What the mistakes that you make on your practice sets will ideally be the mistakes that you will unconsciously make on the actual test, and try to fix those. Okay. All right. Okay. Since there's no more questions, let's wrap up the session at this point. Thank you guys for sticking with me so far, and I will see you next in around 3 to 4 weeks of time. Okay, we'll discuss the time and work bit. Enjoy your weekend. For those who are working tomorrow, thank you for staying up, and I'll see you in 3 weeks time. Maybe tomorrow late evening, 7 India time, or day after in the morning. Okay, I'll have to craft explanations to some of the questions, so that will take me some time, and I have a early start tomorrow for my day, so I'll only get time in the evening. So most probably by day after morning, it should be uploaded. All right. Okay. Again, good night. Have a great weekend.